Okay, it hit 4:35. I'm guessing all of you can hear me, but hello, I'm AJ and I'm the workshop director for Night Hacks. And this is the Summer 2025 Foundation Exam Cram Series. Essentially, for the first 2 days and then a day after the next one, we'll be going over topics for the foundation exam and essentially doing questions and going over notes and things like that to help get everyone more know better of what to do on the foundation exam. And so, is it okay if you scroll down real quick, Adam, so I can see the topics? Thank you. So I think most of you know how the foundation exam works, and you might know how it's structured. And so there's four parts of the foundation exam. You have 2 hours to complete it, and there are 12 questions, three for each section. So you basically get 10 minutes for each question, is the standard usually of what people will say. And so for the first section, part A, the first question, it's always a dynamic memory allocation question, and then the second's linked list, and then usually something, it's between queue and stack. But we kind of made this structure to show how we kind of like made it more easier to understand because different foundation exams will change the questions. Like the third question for part A could be a queue or a stack or infix to postfix question. And so through this exam structure, we tried showing how the basics of like what you might get when you're doing the exam, such as a linked list question might be tracing or coding, which yes, the PowerPoint will be available after this. I think after the third day, I'll make an announcement releasing it to the public so everyone can see it. And so this is also recorded, so if you want to also watch it on YouTube, you can. But for the first four parts, yeah, each section has their own different parts, and then part B will have binary trees, heaps or hash tables, and an AVL or tries. And then part C will have it's basically the math oriented or runtime section. It'll have recurrence relations, runtime analysis, and then summations, or the timing questions, which is like the CERN solving, like the math problem one. And for part D, they'll have recursive coding problem, a sorting problem, which is either code or basically completing a certain step in a given table for like a different sorting algorithm, and then bitwise or base conversion, which bitwise is almost always coding, and then base conversion is the usual math problem. And so, is it okay if you scroll down quick, Adam? Thank you. I'll just go over a quick overview of what each day will have. And so the first day we'll have dynamic memory allocation, linked list, stacks, queues, infix and postfix, and recursion as our topics. And those main topics essentially are a lot of part A and a little bit of part C or D. And then for day two, which is on Tuesday, that will be algorithm analysis one, two, and three, which has like summations and the timing questions and knowing how big O notation works, recurrence relations, sorting algorithms, binary trees and binary search trees, and then AVL trees. And then for our last day, which is Thursday, we'll have base conversion, bitwise operators, binary search, heaps, tries, and then hashing or hash tables. And so this is the first day, so we'll be going over the first day's topics. And so after all that, I'm gonna give it away to Adam, and he'll teach for the topics for this day. Thank you.
All right, thank you, AJ. I hope everybody can hear me. If you can't hear me, please let me know. I don't want to have what happened to me that one time in a lab. Hello, I'm Adam Betinsky, for those who don't know me. I see a few familiar names in the chat or the participant list. I guess will be again, a TA for CS1 with Dr. Ahmed. He's just not teaching this current semester, so I'm currently on a break. But I really appreciate getting the opportunity from the club to teach this. I love teaching this stuff. I find it really fun personally. So hopefully you guys will find this beneficial. Um, if there's anything else before we get into it, please feel free to ask. And of course, you can always also, if you have any questions while I'm teaching, feel free to what was I gonna say? Just unmute yourself or just type in the chat. I'll keep a close eye on both, and feel free to interrupt me. I don't care. So before we get going, anything anybody has to ask, any comments, questions, or concerns? And you can all hear me, right? And you can see my iPad. Okay, perfect. All right, so let's get right on into it. Day one. Good question, Riley. Yeah, did want to cover some quick other stuff about the FE too, before we just start jumping into it. The grade to pass the FE changes. Um, Usually from what I've noticed, yeah, it's around like 55 to 65. It depends on the individual exam. I've seen as low as 50, but usually it's like 55 from what I recall. One other thing I want to talk about before I actually get into the topics. So this is the structure, right? And I know AJ said you have 10 minutes per question about. Um, when you get your exam, I don't know how many, just curious, like, actually, can I do that real quick? Just because I'm curious. How do you, oh, I know there's a way to do this.
Are you trying to make a poll?
Yeah, I was trying to make a poll. If I can, it's fine. I was just curious how many people have taken the exam already and haven't even taken an attempt yet.
I can try it if you want.
Don't worry about it. Let's not waste time with it. So I don't know how many of you are. That's a good question. So time and location. Make sure also before. Make sure you've registered for the foundation exam. That's actually something that's really important that some people don't know about. Close all these tabs really quick. So if you search in Google for like UCF FE, and you can go to this website here, Foundation Exam. Here's where you can find some information about the foundation exam. Um, you have some FAQs in the top right corner of the structure. Remember, as you're studying, you do get this formula sheet on the exam, so feel free to use this. I'll let you take a look at that in your own time. Make sure, most importantly, though, that you've done click the button that says ready to sign up and follow the instructions, because otherwise you will not be able to take the exam, and I'm guessing that closes in the next couple of days or so. Generally, I believe it starts around 10 a.m. Don't quote me on that. And it's usually in CB2. It's this Saturday. If you have SAS accommodations, you will be taking it on Friday. Closes Wednesday. Okay, so the sign up closes on Wednesday. Thank you, Daniel, for that. So, like I said, again, you get 12 questions, or yeah, 12 questions, 120 minutes, so 10 minutes a question. What should do as soon as you get the exam, and I know this might be a little stressful in the moment, you should quickly skim over all of the questions. And they're going to be different topics, as AJ mentioned. And you should try to honestly split it up, like mark the questions into three separate categories. And actually, one other thing before I even get into that, all four of these parts that you see here, they're not all stapled together. They're separated. So you get them all at once, and then you can go into each part in any order you want. You can attempt any of the 12 questions in any order, for those who don't know that. But what you should do is when you get the exam, look over the 12 questions and kind of mark the questions into three categories that like based on your understanding of the material. Like, obviously some people are going to understand like DMA better, and some people are going to understand sorting better, just as an example. But anyway, when you get the exam, you should mark it and well, don't actually like mark the questions, but like take a little note or something and put it into three categories. Your first category should be like you can confidently do the question. Like you can get the question and be like, okay, I can confidently solve this in 10 minutes or less. I know exactly what to do. The second category, if I can write it too, is you feel somewhat comfortable, but like you might need to spend a little extra time on it. You could probably do it in like 15 minutes if you have to. If you happen to finish one of the confident ones sooner, you can do that. And then the third category is you don't feel comfortable at all with that question, um, or you don't really understand what you're being asked to do, or something with the topic. Something doesn't sit right with it. What you should do on the exam, try to solve the part one or the category one questions first. If you have time left over, try to do the part two questions. And also make sure if you do part two, try to do the questions that have the most points first. One thing that AJ didn't mention is that in each part, there are, of the three questions, two of them are 10 points and one of them is 5 points. Obviously, as you can imagine, the 5.1s are a little easier. So if you can, try to do the 10.1s, but if you can't, do the 5.1s. But then anyway, if you have time and you weren't able to get through both of the, or I'm sorry, if you were able to get through both of these, then try to do the third category. Above all, no matter what, do not ever, ever, ever leave a question blank, even if you have no idea what to do. Always, always, always put something down, even if you're almost certain it's wrong, because you never know what partial credit you're going to get. So, any questions on this stuff before? It's always split into four parts, and it's always this structure here that AJ mentioned. Any other questions? Did all that make sense? What I said? Well, that might have been a little confusing. Okay, cool. All right, so who's ready for this? Should we get into it? Yeah, no problem. All right, I got to get used to the fact I'm not teaching in a lab and I don't have to yell across the room. So hopefully I won't lose my voice doing this like that one time. All right, so let's now actually get into the material. Day one, dynamic memory allocation, which I know some people do not like. But unfortunately, it is a major part of this class and the material. Also, one other thing I should mention that I forgot to mention. So obviously, you could study old foundation exams, which is a really good resource. But if I wouldn't go too far back if I were you, if you want something kind of more recent, you could go on Guha's website and look back at his archive for CS1. You could take some of those exams as well, because it's basically pretty damn similar to what's covered in the FE. I mean, it might be slightly easier just because, it's like a class instead of like a standardized exam, but, it's almost like a one-to-one thing. Guha's website, I can show you real quick. If you go to Google and search just his name, Arup Guha, and you put in UCF, don't go to Raymond Professors. If you go here, Arup Guha's UCF homepage, click that, and it's this really basic looking website. But if you go to this Arup's Teaching Information and Archive, and then scroll down to the course, CS1, and then here's some other stuff. I wouldn't really look at assignments per se, but mainly quiz and exam. So, like, here's an exam stuff from like 2022, a final exam. Now, you're not going to necessarily have the answers. He doesn't like to post the answers, although you might be able to kind of mumble your way into it. And if you want to know that, I can show you that later on. But here's some more questions. Here's a DMA question, recurrence relation. So this is just another resource you have. So I just wanted to throw that out there. All right, anyway, now we can actually get into the material if no one else has any other questions. All right, let's do it. Dynamic memory allocation. So remember, dynamic memory allocation is memory that's not destroyed basically when a function ends or a loop ends. It's memory that you tell the computer that, like, hey, I need you to make X bytes of memory, and it'll do it for you, and you save it into a pointer. And remember, there's three ways to do that. You can use malloc or calloc. That'll initially make it. But then if you make memory, say like you have an array of 10 items, then all of a sudden you're like, oh, I need to change it to 20 items. You can call realloc, which will basically extend that size for you. So an example of doing this, the most common one you'll see is malloc. And remember, dynamically allocated memory does not have a name. So you have to assign it to a pointer because the pointer is going to point to the starting address of an array, or it could just be you might allocate a single thing. So let me show you a quick example of what I mean. So let's just make it easy. Let's use integers. So let's just say I want to make a single integer to begin. Let's just call it int star x, and then you just say I want to assign it to equals malloc. And remember, to do this, you have to include the stdlib.h library to do DMA. But you should be able to assume on the exam that all your header libraries are included. But anyway, you malloc, and then since it's just one, you use the size of function. And then I want to say I want an int. And now basically I have two boxes. This is my X box, the pointer. And over here is my new box that can hold an integer, and it's pointing to that. Now, if I want to do something, if let's say I want to assign this box over here the value 10, you could say something like, because remember, you have to dereference it, so you could say star x, equals 10, which would now mean 10 goes into this box here. Does that make sense? That's something I want to mention too. I was about to mention that. So someone just asked, do you have to do typecasting on the exam? Meaning like over here to the left of the malloc, do you have to do like this, specify what type of variable and pointer it is? The answer is no, you do not have to do that. Personally, I don't like doing that anyway to begin with. I find it a little confusing. Because remember, all these dynamic allocated functions, what they'll do is they'll allocate the memory and it returns a void pointer. And then when it spits back the address from this over here, when it sees the data type you've chosen over here, it'll automatically cast it for you. So you do not need to do that on the foundation exam unless you want to. But it's not absolutely required at all. Like you're not going to lose points if you don't put that there. That's just personal preference. So then, of course, you can do this with more than one thing. Let's say we want to make an array of 5 integers. Now let's say int star ARR, and that would be, use malloc again. Malloc, and then we want 5, so you put 5. You put however many you want, unless it's 1. I mean, you technically could say 1 times size of int, but you don't really need to. But anyway, so 5 times size of int. And basically what that'll do, so here's my ARR box, and it's a pointer. And here's this new dynamically allocated array that was just made. Now this is pointing to this. Actually, let me label these indices. That might help. 0 through 4. What this pointer is, the pointer is now pointing to the 0th index. And let's say that address is, I don't know, x10. So it'll hold x10 in this box. And then you could go in a loop and go through everything using the pointer and array arithmetic to assign these values something. I'm not going to do that right now because I'm hoping you remember that, but if needed, if we have time, we can go over that. So here's a question. In C, yes, I was about to ask that. That's what I was going to ask. Can someone tell me what's the default value for malloc? And like in this array, like what's the default value of all these elements right now? It's not null. Good guess though. It's garbage. It's nothing. It's some random crap that you don't want to know what the hell it is. It's really fucking confusing. Sorry for the language. I don't know if I should swear on this. But it's really confusing and it's garbage basically. That's what, I don't know if you've heard that term before, but garbage is basically just computer mumble jumble that you don't want to know. So basically, malloc is good basically for any data type because you can just easily reassign the garbage to anything. You can reassign it to a character, an integer, a float, a double, etc. Now, can someone tell me though, what is cal? Oh, I'm so stupid. It says it right in the slide. It in calc, if you used calc instead, it would initialize what the hell? All of these elements to 0. So only use calc really if you're using integers. But honestly, if you just focus on malloc, you'd be fine. And remember, calc, the syntax for malloc versus calc is a little different, as you can see here. Calc or malloc, you have to do the multiplication. Calc just takes 2 parameters instead. But I hope you can get that from the picture here. And then remember realloc. Let's say, I'll just do a quick example of realloc. Let's say I have this array here of 5, and now I want to add 10 more things to bring it to a total of 15. So what you can do here is then just say, and remember, you have to say, you can't just write realloc. You have to assign whatever it spits out to ARR because it returns a void pointer as well. So you could say ARR equals realloc. So first, you put the pointer first, so it's ARR. I haven't really used realloc that much, that's why I didn't remember. And then you put in the new size. So now I want 15 times size of int, and then basically it would copy over the data to a much bigger array of size 15, and it would all be there, but I'm not going to draw that out for time's sake. So does this make sense how to dynamically allocate memory? Any questions or concerns? I'll take your silence as a no. So awesome. All right, so remember, with dynamically allocated memory, it doesn't get destroyed on its own. You have to be careful and quote unquote, it's called free the memory, which basically tells the computer like, okay, hey, I'm done using this memory I told you to make. Do whatever the hell you want with it now. And it's important you do freeing because if you don't and you lose access to it, you get what's called a memory leak. And if you have memory leaks, your computer's going to slow down a lot, which you don't want to do. It's not fun. So just remember also what a memory leak is, because you could be asked on the exam, hey, is this causing a memory leak, for example? So let me ask that real quick before we actually get into like a foundation exam question. So if I did something like int star x equals malloc times size of int, and then I said, okay, int star y, I'm just going to declare it, and then int star z. So someone first tell me what's the values of y and z right now at this moment? And by the way, if you can't read my handwriting, please tell me. Yes, y and z is garbage because they're not initialized at this time. Now, if I change this to say int star y equals x, is that allowed? Would that cause it? First off, is it allowed? Yes. And then would it cause a memory leak? No. Good. Because I'm just having two values point to the same box. But now, if I didn't do this, honestly, I don't even need the Z. But now if I say int y equals, let me just say int y equals something. Let me do another malloc. So I'll have another y box. Sorry if I'm making this a little confusing. I'm kind of doing this part on the fly. But then now if I say x equals y, does that cause a memory leak? Yes or no? Yes. Does anyone not understand why that is? Okay, we seem pretty good on that. Yeah, exactly. The original address that pointed to X or X pointed to was lost, so you can't access that memory anymore, hence it's called a memory leak. So anyway, if you don't want memory leaks, which you shouldn't do, you have to let's do calling, it's called freeing the memory. So basically, here's an example of that. Here we're allocating an array of 5 characters. So now once you're done with it, you just call the free function, so you literally write free, and then pass in the pointer, the name of the pointer you're using. In this case, it's called PTR. So this would destroy those 5 bytes that you used. Is it bytes? Yeah, bytes. 5 bytes that you used in this case, and then put it back for your computer to use it somewhere else. So freeing is pretty straightforward to do. You just have to be careful though, because it's also possible you might do something called a double free, which you do not want to do. And this is very easy to do if you're looping or doing DMA and like structures and stuff. If you free something once and then try to free it again, it doesn't work because it's gone. You already freed that memory once. So you get what's called a double free error, which you don't want to do because that'll crash your programs and whatnot. Hopefully we are doing a freeing question, so we'll be able to get into this a little more. But then if you have a pointer like we did here, and then we freed that pointer, you can now use that pointer for something else. Like you could assign it to something else. Here, you can't assign the address to like a regular variable. That doesn't work. But then you could just now say, I don't know, if you had n, you could say ptr equals, that's an ampersand, by the way. I can never draw those. The address of n. You could do that. That's fine. So does that make sense, all this stuff? Any questions on it?
I have a question.
What's up?
So when freeing, if you had like a 2D array or a 3D array,
You'll
do
never
you
have
still have to
free.
only free once?
Yeah, every single box that you allocate should only be freed once. Otherwise, you'll get a double free.
Okay, cool. Just making sure.
So, but you might have to do that through the loops and stuff. So the key to freeing, remember, you need to free from the bottom in, like basically get as far deep into like a structure or something as you can and work your way back up. But anyway, some common mistakes here that are mentioned. You have to do a mismatch. Or what am I trying to say? Sorry. There's a mismatch of data types. A good rule of thumb when you're allocating memory is basically here is something like you don't want to do. You can't basically say, oh, I want an integer pointer, but then spit it out to a double pointer. A good rule of thumb when you're allocating memory dynamically is, let's say, just as an example, I have int and I want to do a double pointer error and make an array of pointers. You should be allocating in here in your malloc call. You should be doing int pointers. It should be quote unquote one step down. Does that make sense? So then if you're doing int star x, you should be doing just a plain integer. It should be one step down, basically one less star. You should never be jumping between two. Does that make sense? And also, you should never really be using a triple pointer in this for this exam. Does all that make sense? What I just said there? So then some other common mistakes. Strings, remember, a string is technically in C a character array. So you don't want to, there's no string data type, remember. So you have to allocate a character array. And remember, you always have to do one more than the length because you need the string terminator. You can't forget that. But then here's a bad example. You don't want to do this. Sure, here's a pointer for a char array, but you never initialize it to anything, so it's garbage. So that would cause an error. And then here, you also have to remember 2D array allocation you just got to be careful with. Assigning data to a pointer is an address, remember. You can't just basically not have the DMA saved to a regular data type variable. You can't do that. That won't work. PTR in this case is not a pointer. And then here is a 2D array that was allocated, which is fine. But then you can't use the array syntax here. You only can do the 1D array syntax in this case because technically it's only pointing to a 1D array and not a 2D array. It won't do a 2D array, excuse me, unless you initialize all the pointers up there. Does that make sense? And we'll get into more in depth with this when we're doing like actual questions. I just got to make sure I keep moving here so we can cover everything. Do we feel good on that? Take your silence as a yes. All right, so problem tips that they say to do. Leave no pointer without memory. Make sure to not allocate memory to non-pointers. Make sure the type of pointer, like I said, is 1 degree higher, or if you're going from left to right, 1 degree down. Be careful with 2D arrays. If you're doing a string, make sure to use space for the string terminator. Oh yeah, that's another good thing I forgot to mention. And we'll get into that. Always, always, always pay attention to function return types. Because that's what you should have like your, I guess, quote unquote, grand pointer be. And then, of course, free everything in reverse order. Like I said, from bottom up. Memory isn't, how it's stored isn't, I haven't seen that as much. But just remember, pointers are basically 4 bytes or 8 bytes for a 32-bit and 64-bit system, respectively. And since they store addresses, it doesn't matter on the data type or dimension. And since, remember, tell me this, is dynamic allocated stuff on the stack space or the heap space in the computer? Good, it's the heap, and then static's in the stack space. I never thought about it like this. STA stack. That's a good way to remember it. This did appear apparently in the May 2024 exam. Now, I haven't seen this, but I could see it being asked. Let's just quickly, the 4 common data types: char, int, double. Char, int, and float. Those are the big 3. How many bytes do those take to be stored in memory? How many bytes does a char take to be stored in memory? Can someone tell me that? Anyone else? Just want to see if we can get a few answers here. Yes, a char is 1 byte, just one single byte. An integer is 4, and then a float is 8. No, I've never heard of some standard per se for the pointer part, but for just static integers or data types. So an int is 1 byte, or I'm sorry. No, I got that backwards. It's been a long day. Sorry. Had my first day summer today. A char is 1 byte. An int is 4, and then a float is 8 bytes. So I guess if you want to remember it like this is technically 4 to the 0, 4 to the first, 4 to the second, and so on. So, all right, any questions on that? We should probably get moving now into the actual questions. Thank you. I'm sorry. Okay, forget this. Just remember it's 148. Forget that. Oh no, you want no? I'm so stupid. Sorry, my math is not math around. This is 2 to the 0, 2 to the first, and 2 squared. No, it's not. Okay, you know what? Forget this whole thing. Forget the orange part. Forget that. Sorry. All right. 2D arrays. Let me see. Is this how much more is left after this? Okay, then we're at our first question after this. So, like I said, when allocating the 2D arrays in DMA is hard. You have to allocate the double pointer first, which will basically make. So, like, I can do a quick example. So, if you're going to do a 2D array, you have to do a double pointer out here, which would then point to, let's say there's 4 indices. This would make an array of 4 pointers, which are dynamically allocated. And then each of those pointers can point to a dynamically allocated array of, say, let's say, just 3 regular, just pretend they're ints, I guess, for simplicity. But each of those can point to 3 ints. So again, if you were going to free this, you'd want to free all these dynamically allocated ints first, then these pointers, and then lastly the double pointer. So here's an example of that. You're allocating the 2D array, and you could put all this on one line. They just split it up. And then you need a loop. And using the array syntax, so basically that's saying this pointer's dereference at I, which would access all of these indices, you're allocating memory there. So then they're just using a parameter there to say how many they need. So does that make sense? Any questions? Yeah, in this example here, the DIM1 and DIM2 are parameters that are being passed in, which are the size of how many elements they want in these 2 arrays. So here and each of these. So any other questions? All right. So we have two questions per topic we're going to do. Let's get into the first one. This is a good question. I really like this one. This is from the spring 2024 exam. For those wondering, I took the summer 2024 exam, but I remember practicing this one. All right, so I tried, out of the 10 questions we're doing today, I tried to do more 10-point ones, just so you can kind of get more, like, the harder ones. There's only 2 5-point ones, because at some point I want to give your brains a little break. But let's start off with a 10-point question. Wow, there's 70 people on. That's crazy. Thank you all for coming on and taking your time out of your day to do this. Really appreciate it. And again, before we get into this, thank you, Nighthacks, for asking me to do this. All right, here we go. Starting with a 0-index dynamic integer array, 1D array called base, compute the triangular sum with only the exact proper amount of allocated space needed. No more, no less. By completing the user-defined function definition. The triangular sum is the value of the elements present in the current dynamic array based on the row after the following process. For each row, the current index I will result in the value sum of the previous row, which is row minus 1, at index I and I plus 1. If the 2D array is named trisum, then the process to populate the values of the triangular sum will be as follows. And it's this formula here. Here's a picture. Okay, that's a lot. A lot of these 10-point questions have a lot of information. So when you're given a question, my biggest advice, do not just jump straight into the question. Don't just quickly look at it and make it, oh, okay, I'm going to do this and this and this. Never do that. Always read it 2 or 3 times. Make sure you understand what the question's asking you to do. And then if you need to, and I find this really helpful, draw more examples if you need to. Sometimes it's kind of hard to draw examples, like in this question. I think this example suffices. But if you need to, which I'll probably do in this question, literally draw out a procedure of how to solve this question in English. Then when you make that procedure, you can go step by step by step and translate each step into a segment of code. And when you're done, it'll hopefully work. And whenever you think you have a full solution, try it on the examples that you're given and or that you draw. And if it works, then you're pretty much golden on that question. Does that make sense? I'll take your silence as a yes, question mark. Okay. All right, so this kind of question, let's understand what the question's asking us to do. The first thing I notice right away is that the return type is what am I trying to say? A double pointer of an integer. So basically, we're going to have to do an array of pointers and then an array of integers. So let's just look at what the question's asking you here. So basically, we're getting passed in a 1D integer array, so it's a normal array called base. And that is basically going to be row 0 in here, as we're stated here. So if you're in this picture, it's this and this. This is technically how it's going to look in the computer, but this here is just a nicer visual representation for our own human sake. So we can see this array here is base. In fact, let me write that here. This is the base array. So what we have to do is basically, using this base array, dynamically allocate space for that base array and then X number of rows. And then after we make all those rows, what we have to do is then basically fill it in using this formula. Does that make sense? So I can write out those steps again. Like I said, and again, I find this really helpful. This helped me a lot. So one, what we need to do is first allocate. We need to allocate the 2D array. Well, I shouldn't even say 2D array. We need to allocate the double pointer. Because we're going to eventually have pointers. Because all of these here, these are pointers. Let me use this picture now. All of these it looks like rows, but these are technically pointers that are pointing to each of these plain old integers. Does that make sense? Maybe I could star all of these just so that makes more sense. So those are all pointers, technically. That's being pointed at from a double pointer up here, and that's pointing to the 0th pointer. So we need to allocate that first, right? Now, after we do that, how do you think I'm going to want to continue? Okay, first, actually, before you even ask questions, do you understand what the question's asking you? Asking us to do? Okay, roughly is okay. That's fine. Even if you have a rough idea, that's good enough to get into it. So, and again, for those who don't understand, so this is an array this array here is being passed into the function. And then each of the following rows is one length smaller than the row above it. And it's getting, oh my God, I hate when it does that. It's getting the data value from the previous two indices in the above row using this formula. Does that make sense, Zishan? Okay, cool. So now, once we allocate the double pointer array, so basically once we allocate all of this, what do you think I'm going to want to do now? Any guesses? Well, obviously a semicolon, yes. But, okay, so this is good. I'm liking this. I'm liking how we're getting very different answers here. So, this is where you just need to take it slow. How could we know, possibly? I'm seeing a lot of people are saying loop through every index right away and malloc everything. Do you think we could do, if I haven't allocated everything yet, do you think we could do that right away? Yes or no? You could, yes, technically. But if you think about it, it's going to be a lot easier to just deal with the base first. Because we have to copy that base into this new double array here. Remember, or I'm sorry, we have to copy over from the base that's passed in. So doesn't it make sense to take care of that first? Because then we could tackle all of this stuff at once. You could do it where you allocate all the space first and then do all the numbers. But for simplicity's sake, wouldn't it be a lot easier just to go, you know, deal with the beginning first and then tackle all the rest at once? Does that make sense, what I'm saying? Okay, cool. So now we have to take care of the base. So we have to take care of the base. So obviously, well, maybe not obviously, what's step one of doing that? I'll label it 2A. Can I just copy everything over right away? Or do I have to do something else first? You have to malloc the base, good, because this has to be DM'd A in our 2D array. So we have to allocate the memory. I'll just say allocate. And then we can copy everything over, right? So we can copy it all. Then we'll have row 0 ready to go. Then what we can do is now take care of the rest. So now if I want to do the rest, what do you think I'm going to need to do? How could I tackle, now that we have this allocated here, how can I tackle the rest? Good, we're going to need a loop, but give me more details. Am I going to need a single loop, you think? A double loop? Can I just start copying? Like, base is just a 1D array that's passed into the function here. And here's an example. It's just like 1, 2, 3, 4, 5. But you need to copy that over to make it the first row in this mess we're making, the triangular cell. Yes, we need a double loop. Good. Because each row is less than the previous. Yes. But do you think, do we need to allocate first or can we copy first? Or is there something else we need to do? Yes, Sebastian has it right. We need to allocate each row as we're going along, and then we can fill it in. So we can allocate the rows, and then we can fill in the rows. And then once you do all that, you'll be done, and you'll have this nice, weird thing created. So does that make sense? Do you find it helpful to kind of do the procedure kind of thing? Then you can just follow yourself step by step and hopefully not make a mistake. All right, cool. So now let's follow this procedure and actually write the code. All right, so since the return type is a 2D or a double pointer, that's what you should make the outer, like the first thing. So now let's call it int double pointer, and I'll call it ARR for simplicity. One other thing I forgot to mention too. For something like, if you're given parameters or structure name, you have to use the ones that are given to you. So like I can't call base like X, or for example, or I can't call N X. If you do that, you're going to lose points. If you're given something that's important, that's used in the coding, you have to use the name that's given you, or the structure name that's given. That's something else also to look out for. But anyway, so I'm calling this ARR, since you can call whatever you want here. And now, who am I going to call? I'm going to call malloc. But now, what am I going to want to put in here? Now remember, initially we're just allocating the base array, as we said here. We're allocating the double pointer. And we need n elements because that's how big base is, and it says it here. You don't need to do it. You really only need to do a null check, Ellie, if you're not allocating any. Like if you're allocating memory, you don't need to bother checking like if it failed to allocate. Just assume that it works. Like there's no like allocation error like from the computer's end. Like it's possible you might make a mistake in the code, sure, but Yeah, null checks are usually for like recursive functions as base case. But she was asking Zishan, basically like if ARR is null, basically return like an error. You don't need to do that. But anyway, so we want to allocate this row 0 array base so we can copy it over. So how would I want to do that? I'm sorry, you know what? We don't want to do base yet. We're still allocating the double pointer. I'm getting ahead of myself. We need to allocate all this. That's what we're doing now. So in this case, you happen to notice this and this are the same size, and this one here is base. And the size of base is n. So what would I want to put inside my malloc call? Can someone tell me? You got it. So it'd be n. It doesn't matter the order you put. So I'm just going to do n times size of an int pointer. Cool. So now we have this. So step 1 is done. Now we have to take care of base. Step 2. So now, first we allocate the base. How would I want to allocate the base, you think? Do you think I want to start looping yet? Actually, we talked about that. No, we don't. So how could I allocate the base? Yes, you have to malloc at ARR at 0. Good job. So you'd say ARR. No, you don't want to make an empty array. Well, by empty array, do you mean like on the side or like using this? Because if you mean on the side, you don't want to do that at all. But yeah, we're basically going to create an empty array within this first row here. And because it's the first row, we know it's ARR at 0. On some of these questions, you might have to do 1 or 2 steps explicit like this. So then what would the malloc call look like? Malloc what? You're good. Perfect. N times size of n, because again, there's n elements here. N, oops, oh my God, I hate when it does that. I don't know why it keeps doing that lately. N times size of int. All right, cool. So now we have this. So we've completed step 2A. Now we can do 2B. So we need to copy everything over. So I'm going to have to do something over and over again. What am I going to need? A loop. Perfect. So this, I hope, is pretty self-explanatory. For int I equals 0. Oh my God. I don't know what I'm doing that keeps doing that. Whoa. What the hell? Is it going to behave? It's not I don't have an Apple Pencil. I'm using a different stylus. It's just the app. I'm touching something wrong. I equals 0. What's I going to be less than here, you think? N. Perfect. I is less than N. N plus plus. Okay, by the way, that's a brace. I just cannot write braces for my life. So now, how am I going to access each index? Oh yeah, I plus plus, sorry. I plus plus. How am I going to access each index? I isn't 1 yet because we're still dealing with row 0 here. Yes, try some at... Oh, be careful. I see we have a few different answers. Remember, is the row changing or the column changing here? The row or the column's changing. These, if you think about it, are columns. So the first part, the row, is staying the same. And all of these are changing. So we'd want to be 0 and then I. But yes, you got the ARR part. So it'd be ARR 0 I equals what? Base. We were just copying it over at the same index from base. Base it up. So now, after doing that, we finally have we finally have this first row fully allocated and ready to go. Does that make sense? Because you can't directly add, well, first, you can't add base in an array of 0 because it's more than one number. And also because the question is asking for the exact proper amount of allocated space. So if you were doing it statically, it'd be extra space that you don't need. Because the function doesn't know otherwise how many elements it would need. Does that make sense? Okay, cool. Okay, so now we've done 2b, which satisfies 2. So now, oh, that picture moved over. That's what happened. Now we need to allocate the rows. So now we need to be careful here. So as you guys said before, I'll get it. It's going to take a little time to process, I assume, because this is a long meeting. But ask AJ that. He'll know the answer. Someone will probably know the Discord server. So then we now have to allocate the rows. So as you both, or not both, as you all said, you need a double loop. So now let's be careful doing this. Take it slow. Let's first do our outer loop. So it's going to be a for loop again because we know how many things we need to do. So we can use I again, but just because it looks like this with row and I'm going to do row just because so it's consistent. So if int row equals, now what would I want row to start at, you think? Good, 1, because we already took care of row 0. So when row equals 1, what is row going to be less than? And you can take a look at the drawing again if you need to. N. Don't put an explicit number here because we don't know whatever n is. But you just put n. Row is less than n plus plus. Oh, I'm sorry, row plus plus. I did that again. That was what was with me today. So now we're going in this loop. So now we have to be careful here. Before we fill in the rows, we have to allocate the rows. So this is pretty similar to what we said. It's pretty similar to this up here, except instead of it being 0, instead of it being an explicit number, we're going to use our loop variable row. So it's going to be ARR at row equals malloc. And then it'd be size of int, because we're doing ints. Now, and again, we're going one step down, because remember, this is technically a pointer, a single pointer. But now we're going one step down. How many am I going to want to put in here? And if it helps, let me put the size. I think that'll help you look at the picture here. This has 5 things, 4, 3, 3, 2, 1. And remember, n is 5 in this case. Be careful, because remember, we're in a loop here. N minus row, good. Because in this case, n minus 0 is 5, and then 5 minus 1 is 4, 5 minus 2 is 3, and so on. So that's how many elements we want to allocate for that individual row. Does that make sense? Because this will create n minus row elements in this row. All right, cool. So now we've completed step 3, and we can do 4. So now, how am I going to fill in the rows? You need another loop. Perfect. So it's a nested loop here. So 4. Now I'm doing I again just because that's what that formula was above. Usually I put J. What's I going to begin at, you think? You can't do the formula right away because you have to access each individual element first. Yes, 0. Perfect. Now what's I going to be less than here? N minus row. Perfect. Because that's how many elements there are. And then I plus plus. So now we're going to actually copy all those individual elements over, which to do that is based on this formula that's given. And actually, literally writing that down is 1 point. So try, so, oh, so like, see, oh no, you could call it ARR, that's fine. ARR at row I keep leaning on the iPad, that's fine. What do you mean initialize I again, Victor? Yeah, what they said. So now I'm just using that formula. So now it's copied all the elements over. So now this whole thing is filled up. So now we can be done looping, right? Because we don't need to do anything else. So I'm going to close this loop and then this loop. And then what's the last step? We return ARR. Return ARR. And that's it. That is the complete solution to this question. We're doing n minus row, Ellie, because so in each element we need, you see, it starts at n, but then we need one less. There's one less thing than there was in the row above. So basically, we have to in order to tell the computer that, you have to it just works out by looking at this. There's n is 5, remember, n minus 0 is the row in that case, and it's 5. And then in this case, n minus 1 is 4, which is what we want. N minus 2 is 3, which is what we want, and so on. So that's why it's n minus row. Yeah, you do not need to free the memory unless it asks you to. So that's the solution. Any questions?
I have a question about the return.
Yeah, what's up?
So when you're returning array, aren't you returning everything?
Yeah, and that's what you want to do.
So, okay. If they were to change the question to, let's say, return a specific row,
Uh-huh.
would you just do it's the same thing, but then just brackets in between with a number, correct?
Yeah, it'd be like, you could just say, if you wanted the 0th row, you'd say array at 0.
Okay, cool.
But
Just
then
making
you'd
sure.
have to change the return type. The return type would have to be a single pointer, not a double. And then if you had this and you returned a single row, let me ask you guys this: would that create a memory leak? Yes, because even though it's dynamically allocated memory, once you return, anytime you need a return statement, it's over. You can't access anything else in that function call, so you lose access to all that memory. So that would be very bad memory leak right there. So, all right, any other questions before we move on? Hopefully, I'll have to pick up the pace a little bit here. That took a little longer than I'd hoped for, but keep moving. Did you guys like the procedure thing? And again, you don't have to do that. I just find it helpful. All right, so oh,
Is that how you also did it in the foundation exam, or did you just think about everything in your head?
no, I literally wrote this out like on a piece of paper on a question I did.
Okay.
I don't. So I took the exam at SAS, so I'm not sure. I think everyone else is given scratch paper, but I'm not 100% sure. I mean, if you have to do what I just did, squeeze it in somewhere. Anyway, so again, here's that solution. You can look at the rubrics later, but there's that. Okay, are we ready to keep going? Let's do it. Okay, so here's another question. Sorry. Okay. Considering the following type def structure definition that represents a book. So a 2D character array with sentences, so it's an array of strings basically. And then we have the total number of sentences in a book title, and a book author. Complete the following user-defined function definition that properly deallocates all the memory associated with the heap space of the struct type book T. The parameters of the function contain the reference to the heap space of where the array of book T is stored along with the total number of elements as num books. Note that within each type of book T, sentences is an array of num sentences strings. Okay, where each string was dynamically allocated, as were the strings, title, and author. Okay. I think this is going to be a lot easier to understand as an example. This is a good example question. Like you can see, like some of them are better to do an example on, some are better to do the procedure. There's some you can do both. It just depends on the nature of the question. So let me do this down here. I might have to move this after. So basically, we have a pointer, we have a book pointer here, a book T pointer rather. And what that's pointing to, remember, this book pointer is dynamically allocated as it's stated here. So remember, each book T has all of these things in it. And all of these pointers, as we were told, are dynamically allocated. So we have a title. There's 4 boxes basically. So we have an int box, which is containing the number of sentences. Now let's say there's 3. Just keep it simple. And then we have a character array, a 2D, a double pointer basically, of sentences. So basically what sentences is, so we have out here sentences is a double pointer pointing to num sentences number of sentences. So in this case, there's 3 pointers. And these are char pointers, by the way. Each of which are dynamically allocated for some amount of characters. Let's just say it's 4. I don't know. So each of these would have an array of just 4 characters. Oops. Now I'll just put C's in these for char. But it could be whatever the heck. It could be any character. Actually, let me say that again. The N is not a character. This is the terminator. Remember that. So that's sentences. And then title is another box, a pointer, which is pointing to another dynamically allocated character array. And let's just say, I don't know, I'll just call it ABC. That's a string. And then we have another one for author, which is basically the exact same thing as the title. And let's just say the author's name is Bob. And remember, all of this is in one allocated book, but we're only being asked to free one of them. So does it make sense how I got all this information out of the question? Okay, cool. Okay, so wait a second. Let me see something. Oh, okay, never mind. All right, so what we need to do is free all of this memory. So where do you think we want to start? Tell me, which variable do we want to start at first? Yeah, I would always start with whatever's the biggest, in this case, the sentences. So let's just start there. So how are we going to access that? Let me move this up. Hopefully this example makes it a little more clear what we need to do here. Oh, come on. That's there. Let me do a different color. Okay, so how are we going to access the sentences? Well, what do we need? If we're freeing more than one thing, what do we need? We need a loop. And as someone said, a nested loop. Yes. So for int I equals 0, and then what's I going to be less than? Well, as we were told, the array of we are actually, my apologies, we are freeing an array of books. So let me modify this drawing slightly, actually, before we start coding. My apologies. This is why it's important not to jump straight into the question. Always read it a couple times. So technically, we have this. Let me modify this slightly, real quick. So we have a book T box. And let's say it has 3 books. So book, book, oh God, book, book. And then each of those 3 books contains all of this crap. So basically, they're all connected. Does that make sense? Okay, cool. Now I'm going to make this smaller. Okay, so we need to clean up all of these books. So we need a for loop, as someone said. For int I equals 0. I is less than... Whoa. Wow, there's what the slides look like, really little. Hey, it almost looks like a bookshelf. That was a first. Jeepers. Okay. I don't think my iPad likes me teaching again. Oh, that was the answer. I don't want to see that. Oh no, where'd it go? Oh, phew. I thought I lost everything. Okay, my bad. Okay, so I is less than. What are we going to want I to be less than? Number of books, because we want to do this for each book. I is less than number of books. Or, see, like this is a variable you have to use the name of. You can't make it up. I plus plus. What happened? It's ironic. Okay, we just lost the question somehow. That's great. Um, Let me reboot Notability. That might be what's going on. Okay. Damn it. Okay, let me put that question back. It's gonna be really small, but okay, there it is. So I is less than num books. I plus plus. What is wrong with this thing? Oh, it's back. It put the old one back. Great. Even better. It overlapped the drawing somehow. Uh, um, okay. Yeah, my palm's I gotta be really careful with that. Um, does anyone need me to fix the drawing? Can I leave it like this? Honestly, save time. Okay, I'm leaving it. Oh, it did this too. What the hell? Okay. Well, this will go in the books. Probably the most interesting FE prep workshop in a hex. Okay. 4. I gotta be really careful. Wait, actually, there's a setting for that, I think. One second. I know it's there, some gestures. No? Or whatever. Forget it. And I equals 0. This is just the problem being a lefty. I is less than num books. I plus plus. Okay. So now we're going through each book. So now, as someone said, we need to free the sentences. So how am I going to access each of the sentences? I'm sorry this drawing's so bad. Yes, we need another loop because there's more than one. So for int j equals 0, because we're starting at the beginning again. Because, yeah, we need another loop because we're doing more than one sentence. We have to free. J is less than... What would J be less than, you think? And look back to what we're given. Look at the drawing. Yes, num sentences. We have to be more specific. Because each book could have more than... Like, each book could have different number of sentences. So how do I access that book's number of sentences? Yes, lib at I dot num sentences. Good. That's saying, hey, I want lib at this book, that index, that book, so at I dot num sentences, and then, sorry, J plus plus. No, behave. Stupid iPad, man. J plus plus. Okay, so now how would I free each of those sentences? Yes, that would be wrong. You have to be careful with that here. You're not dereferencing. You don't need to if this was like a structure, if this was like I'm making this up. If this was like, just say you have some structure called app, then you would need to dereference it. Yes. But not in this case because it's just an integer. Yes. Ellie's got it. You need to free, you have to specify. I want to free that books at I in that specific sentence at J. You're using kind of that 2D syntax here. So I'd free and put in parentheses lib at I dot sentences now, because that's the actual 2D array at J, which actually will now then it'll access each one and free each of these sentences individually. Does that make sense? Yes, that's one other time you use the arrow. So does that make sense what we've done so far? Okay. So now we've done that. Now, do we need to keep looping? The nested loop? The inside loop? No, because that's the only thing in each book that has more than one thing. So now, what do we have left? We have the title, the author, and then tell me this. Do we need to free num sentences? No, because it's static. Do we need to free this guy? Just the original sentences? Yes, good. So we have 3 more things to free, but it's a lot easier now. There's no more looping. Does the order matter of what we free these 3 things in? No, it does not matter at all. So someone tell me let's just do the sentences, finish it. What would I say here? Free what if I want to free the current book sentences? Perfect. Limit I dot sentences. Then what if you want to, let's now free the title. What would that be? Well, it's pretty similar, just limit I, but now it's the title. And then lastly, the only one left is the author. Sorry, my handwriting's messy. Cool. Are we done? No, we are not done. Good. I'm glad a lot of you said no. We still have to free the book array out here. So we need to free lib. Perfect. But we don't need to do that in a loop because it's just one overall pointer. So now we can close this loop and say free lib, the actual like overall library. Now are we done? Yes, that is the final answer. By the way, I'm looking at the rubric here. If you used arrow once at all, it's only 1 point off. So that's really not too bad. if you ended up using the arrow. The bulk of it looks like, was really doing this part here. Any questions before we move on? No, you don't need to free lib at I because these are all static. Well, no, let me say that again. They're dynamic, but book T is pointing to them. So it takes care of that for you. Or in this case, book T is lib. That's what this is. So, any other questions? So yeah, Kane, if you used an arrow, you'd lose just 1 point on the whole question overall, which really isn't that bad if you ask me. So, all right, DMA is done. We're ready to move on to next topic. Yes, yes. What Chris said is correct. All right, let's take a quick 30-second breather and then move on. All right, that was not 30 seconds, but I just want to get going. So here's that key again. And why is CVS texting me? I don't give a crap about free minute clinic sneeze testing. All right. I already covered questions. All right, next up, linked list. I love linked lists. I think they're really cool. So what's the motivation behind a linked list? The biggest issue with arrays normally is that there's like a plain old array is that they're static and it's contingent, meaning that once you declare it, you can't change the size at all. And the problem with it though is that the runtimes are typically worse than arrays, and algorithms like binary search are impossible. Inserting something's quick and easy at the head because you know where it is. It's right at the beginning. But if you want to insert something at the tail, you have to loop through the whole list, right? If you want to insert something down here, you have to loop through and actually find the tail and then insert it. Same thing with searching. You might have to search the whole list before you find what you're looking for. And then sorting is not even covered. I'm going to try to go a little faster on like the overview now, just so we have time to get to the actual questions. But if you have any questions like with the overview, feel free to ask. So there's three types of linked lists. There's singly linked lists. So like this, you just have an element and a pointer to the next node. A doubly linked list, which is the same thing as a singly linked list, except each node also points back to the previous node if it exists. And then a circular linked list, which is a single linked list, except at the end it points all the way back to the head. It keeps going around and around in a circle, basically. Does that make sense? Am I going too fast? Okay, cool. So to traverse a linked list, you basically you use the head. I find it easier to use the head. It's something like this. I don't like calling it temp. I don't know why. In my brain personally, instead of calling this temp, I call it walker. It's like I'm saying, okay, that's a walking variable. But that's just me. You can call whatever the heck you want, unless it's specified. So usually you grab the head node just to make it easier on yourself. Then you just use a while loop that loops till the end of the linked list. So basically until the walker is null, because then the list doesn't exist anymore. You do the operation and then just increment the walker forward. Does that make sense? All right, cool. Hopefully this is pretty much reviewed here. So there's two types of linked list problems. We're going to do one of each. We're going to traverse the linked list, and then trace a linked list. Does anyone have a preference on which one we do first? Who wants a break from coding? Who wants to do just a tracing question? Like this is a tracing question here. I figured you want tracing. Okay. Skip over this. Okay. So here's the tracing question. Suppose we have, and this is a 5-point question, so it's supposed to be easy or easier. Suppose we have a singly linked list implemented with this structure here and a function that takes in the head of the list. If you call the function what's called what do you do head on the following list here, what Show the list after the function is finished, and you fill in these slots below. So I'll zoom out. I'm going to give you guys like 4 minutes to try it, and then we'll go over it together. Does that sound good? And what I'll do, I'll set a timer just so we can stay on track here. I'll set a timer for 4 minutes. So give this one a shot on your own if you can. Cool. I think, can you see the timer? Yeah, you can. Perfect. All right, cool. Good luck. We'll be back in a couple of minutes. Sounds like Disney music. All right, how'd we do? Did anyone, if you got an answer, share what you got in the chat. Curious. Seems like most of you got it. Good job. It's 25817. And now let's trace it. So for those who didn't, you can see why. What was that? Did someone just make a noise? Or am I tripping? I don't know what I just heard. All right, so remember, in this drawing, I don't love this drawing they used. I'm going to erase the head because if you think about it, 5 is the head. Same difference. I don't know why. That just sits better in my brain. All right, so let's take a look at this. We're calling the function and we're assigning a variable called temp to the head. So this is temp. And then we're assigning temp2 to head's next, which right now, head is 5, so its next would be 2. So that's where we're going to put temp2. Okay. So now we're going in, we're declaring this int a here on the side, and it's not initialized yet. Okay, so now we're entering a while loop, which we're going to traverse it. Okay, so we're going to check. Is temp's next pointer null? Is it? No, because 2's next, or 5's next is 2, and that's not null. So we're going to assign a to temp's data. So in this case, 5. And then we're going to assign temp's data to, let me maybe draw it out over here just so it's a little easier. Oops, sorry. I'll keep the pointers up there, but it's a terrible sum. Let me just copy this down here. Sorry, I should have done that from the beginning. Okay, so then we're going to change temp data to get temp2's data. So now this is going to get, this becomes a 2. And then temp2's data is going to become a, and a is 5. So in essence, they swapped values. And now temp equals temp's next, which is where temp2 is right now. So these are both currently pointing to the same thing. Now we're going to see, is temp's next pointer null? So is 5's next null? No, it's not. So now temp is going to get incremented to temp's next, which is now 1. And then temp2 is going to get incremented to that as well, the same values. Let me do this now, just so it's easier. They're both pointing to 1. To 1. There we go, it's better. They're both pointing to 1. Does that make sense what I've done so far? All I'm doing is just going line by line in this loop now. Any questions? Confusion? Is it 8? Did I make a mistake? I might have. Because we did that, they swapped. So temp was at 2. Temp was not. Sorry, I'm just thinking back. I might have made a mistake here. So this was temp, this was temp2. See, even the good people make mistakes sometimes. Only human. So temps, we did this. So temp equals temp next. So there. And then temp, it's not null, so then temp's next. Oh, yeah. So this goes here, and then temp's next is now 8. So temp2 is going to go to 8. My bad. Sorry about that. Just need to visually see it again. My apologies. Okay, that's what it should be. So now we've hit the end of this iteration of this loop, and we're going to do it again. So now just follow it all out. So A is going to get temp's data. Temp is 8. I'm sorry, temp is 1. It's going to get 1. Then temp is going to get temp2's data. So this becomes 8. And now temp2's data is going to get A, which is 1 right now. Now we're going to move temp to temp's next. So they're both going to be pointing here. Now we're going to look. Is temp's next pointer equal to null? No, it's not. So we're going to move temp over to 7. And then we're going to move temp over to 7's next, which is null. This is the null space now. So now we're going to look. Is temp's next null? Yes. So you're done. So the final answer is 2, 5, 8, 7. If you think about it, it's just swapping every 2 elements if it can, up to the last element. So does that make sense? Any questions? Sorry again about that mistake. All right, so now let's go back to, well, here's what that looks like. I didn't know partial credit on this kind of question. So now let's go back up to the coding question. Okay. So I was doing something. The structure of a node of a doubly linked list. Be careful here. A doubly linked list is shown below. Write a function that takes in a pointer up to the head of a doubly linked list and a pointer to a node in that list called me that removes that node called me from the list and returns a pointer to the head of the node, to the head node of the resulting doubly linked list. You may assume that both head and me are not null, and that me points to a node in the list that's pointed to by head. Okay, so what this is asking you to do is basically, let's just say we have this 5, 3, 1, 7, 8, 2, each of which point back and forth to each other. Because it's a doubly linked list, you have to be careful. Can I paste, please? What's wrong with this? Did Notability update in the past like 5 minutes? Oh no, it's getting the picture. Dang it. There we go. Bad. Dang it, I did it again. Someone had a nickel for like every time I mess something up on the iPad in this meeting. They'd be rich. Let me see. Here's okay, there we go. So here's what it looks like. So now let's say, so what would head be in this case? 5. So if we're getting passed in 5 as the head, and let's say me is 1, basically what needs to be done, we have to delete 1 basically and reallocate the pointer such that all of this doesn't exist. And now 3 points to 7 and 7 points back to 3. That was a terrible 7, by the way. There we go, that's better. Does that make sense what we're being asked to do? Okay, cool. All right, so yeah, well, basically, yeah, it's the pointer technically, but in the example, let's just say me is 1, just to be able. But the coding question's not really, just because I'm probably already taking much longer than I should be to go on each question, so I just want to make sure we keep moving free enough. If that makes sense. I honestly partially gave you solid time in the last one, so I used the bathroom real quick. But I'm good now. So okay, so we have to be careful here. So remember, each of these nodes are dynamically allocated. That's something first to remember. So let's just start with the easy stuff at the end. I think that's the most simplest thing to do. Once we find, this is after we fix all the pointers and stuff. I think it's going to be easier to start at the end and keep going. So once we finish all the pointers, we need to get rid of me, right? So how do I get rid of that node we've allocated? What would I write here? Yeah, free me. Sounds really silly. I guess a get out of jail free card for me. Okay. And then that's pretty easy. And then once you do that, what does it say you need to return? Return the head. Yeah. So we're going to return the head. I'm only doing the end first on this question because they usually don't ask doubly linked list questions. So I'm just making sure I want to do the easy stuff first that a lot of you could probably figure out. Okay. So when we find me, what do we have to take care of? Next and previous. Now our next and previous can always exist. No, good. Not necessarily. So now, before we do that, is there any other special case you have to be careful of here? Just think about it. Not head. Where we were told if head would not be null. It says right here, just make sure you look back. You may assume that both head and me are not null. So that saves you time. Not if next is null. Yes, if me is the head. Because if me is the head, it's a very special case. So you don't want to do any traversing at all. Well, actually, you don't even need to traverse in this case because you're guaranteed it's in the list. We'll take care of me as last in the list because that's easy to go back and forth. But we have access to the head. We're given that. So if me is the head, you have to take care of that and use the head because then we have to update the head to be the next node in the list. Does that make sense? Okay, I only got one yes, so I want to make sure that makes sense to people. Now, I need me to repeat what I just said. Okay. So let's take care of that case if me is the head. So I think that's pretty self-explanatory. If me is the head, I guess technically that's true in people. You are technically whatever your brain is, so in your head. I don't know, just stupid stuff. I don't know why I was going like weird tangents like that. So if me is the head, how am I going to update the head? What would I write? They're both correct. Now that I think about it, Guha wrote head, but you could do me not next to if they're the same. It makes more sense. You don't need to. We're gonna do the freeing of me at the end, Zishan. That's what we already took care of down here. We'll do the freeing right at the end. You could do it there. Well, actually, no, you wouldn't want to do it there because, well, I guess you could, but if you didn't do it there, you'd have to do it in your other if statements too. So well, remember, if me is the head, if me is the head, we're just gonna update the head to be the next one. So then we'll update if me was the current head, the old head, we'll still free it down here. Does that make sense? Um, Jacob? Okay, cool. So we'll just update the head to be head is equal to, and again, you could say me or head next here. I'm just gonna do head next because in this case are the exact same. Head next. Okay, cool. So now the head's taken care of. So now in this example, head would be 3. Okay. So now we have to be careful of this. Yes. So now we need to take care of the next and previous node, the pointers. So let's take care of the next first. How would we, and now this isn't any case. So let's say again, me was 1. Because the head part's just easy. We just move the head forward and then we have to take care of me. So we could take care of if head was 1. Let's think about it that way. If this was me. If me was 1. What would I want to, can I just update the pointers right away? Or do I need to do something first? Do I need to check anything? Okay, yes, check, but what am I going to check for specifically? Let's just assume, let's just do next first. Forget previous right now. We'll do one at a time. Let's pretend we're doing the next first. Yeah, you have to check if they're null. Like imagine you're at, because what if me is 2, for example? If that's the case, you don't want to do any, you don't want to update any pointers. So basically yeah, we check if me next is null. So if me, now am I going to want to use dot or arrow here? Arrow, good. If me's next does not equal to null, because that means we do need to update something, how would I want to what am I going to write in here? It's one line. And look back at the drawing. If one is me, how would I update me's next? So how would I basically make 7 point, or how would I make 3 point to 7 now, basically? I should reiterate this for a second. What we have to do, it's weird because we're going to check if the next exists, because if the next exists, we have to update the previous to point to the next. Does that make sense? Does that make sense what I just said? See, this is why it's weird with doubly linked lists. I want to take some time with this one. Like I have one yes. I'd like more than one yes. And if you don't understand that, that's fine. I can explain that again. Does anyone need me to reiterate what I said a minute ago? Okay, I'll take your silence as a no. So yeah, I see a few people said me's previous next equals me's next. Unfortunately, that's not correct. Again, let me reiterate this one more time. So if a node exists to the right of me, so in this case, if me is 1 and 7 is the next node, it exists. We need to basically say, okay, I need the previous of me 3 to point to me's next 7. You don't need a temp. You can do this in one line. So tell me this. How would how would I basically, let's just take this slowly. If I'm at 1 is me. How would I access if I wanted to tell 3 to point, not telling it what node to go to, just if I want to access 3's next index or next node using one's or using me's syntax? How would I access me's previous and what that's going to point to next? Yeah, me previous arrow next. It's really confusing. Me prev next. Does that make sense? So I'm basically saying me's previous, so 1's previous, 3, whatever its next is. Now we need to update that to 7. So now how would I update that to 7? Look at the picture. Hold on one second. Yes, that's right. You know what? I made a mistake. I was looking at the wrong part again. My apologies. This up here, this should be if me previous is null, not null. Sorry. Because if that's not equal to null, then you need to do this. Because if there's a previous, you have to update the previous. Does that make sense? Sorry about that. I was looking at the wrong part on the solution. But yes, so now basically what this did is what we wanted it to do. A previous exists from me, and now we're updating me's pointer previous to point to me's next. So 3 would point to 7. No, I would do them separately. It's just easier that way. So now we've done the previous, now we have to do the next. And now it's pretty similar. So now we have to check if a next exists, right? So if a next exists, so it would be the same thing. If me arrow next does not equal to null. So now I'm basically saying, okay, now I want me successor 7. I want its previous to point to 3. So what would that look like? Oops. What would that look like? You got it. Me's next previous is going to equal me's previous. Good job. Does that make sense to everybody? Why that is? And then the rest is we just free, because after we update the pointers, we free me and then return the head. Go over what specifically? What we just did here? Yes, you don't need to traverse since you don't need to traverse because you're not only are you given the no, but the important thing is that you're guaranteed me is in the list pointed to by head. If you weren't told me was in the list, you'd have to traverse and check first to see if me was in the list. Does that make sense, Sebastian? And then in the last if statement, what we need to do basically, so if a next exists, we're basically doing the opposite of what we did here. If there's a successor to me, so in this case 7, we have to basically update 7's previous. Whoa, I just did that thing again. We need to update 7's previous to point to me's previous, which is 3. So what that will do is we're saying if a successor exists, which is me's next, we have to see, okay, we would say me's next, its previous is now going to become me's previous, which would essentially make it, instead of 7 pointing back to 1, 7 would point back to 3. Does that make sense? Whoever asked that? Yes, we have to check if it's the head, which we took care of here. Because if me is the head, we just have to update head one more to the next value. So now this is a good kind of question. Let's check if this works. So let's say me is 1. Is me the head? Actually, I already kind of explained how it works. A lot of you said you were confused about the edge case. This would work if me was the head. So right now, let's say me and head are 5. So if me is the head, which it is, if me is the head, which it is, we're going to increment the head to the head's next, which in this case is 3. Now, is me's previous null? Or is it not equal? Yes, it's null. So we skip this second if statement entirely. Now, is me's next null? No. So now we have to say me's next previous, which is, so me's next, 3. Its previous, we want it to now point to me's previous, which in this case is the null space, which is exactly what we want. We want 3's previous to point to null because it's the head. So that would point to null, and then all of this would go away once we free me. Does that make sense? How that works? And it's the same idea with the tail, basically. So any other questions with this question? I know this one was a little confusing because it was a doubly linked list. So that's why I want to. This one's really one you got to take slow with the drawing. The drawing's kind of critical for this one, in my opinion. So anything else before we move on? Yes, previous would always exist if it's not the head, and next would always exist unless it's the tail. Good question. Whew, all right. You have to do the null check because if you executed this here, like if you're doing the edge case where it's the head, for example, where me is the head. If you did this here, you'd basically be assigning null to a 3 to a value, which you can't do. That's a seg fault. Does that make sense, Zishan? So, any other questions? Okay. I hope we don't go over. I have a feeling we might go a little bit past 7:30. I apologize if that happens, but I hope, is everything making sense so far? I hope. Okay, I'm glad to hear that. I'm glad to hear it. Thank you. All right, let's move on. Cues. All right, let's quickly fly through the basic stuff. So what are cues? Cues are just linked lists, except they have a first in, first out property. So basically, a queue, think of something like, okay, you want to buy tickets to Epic Universe, and there's 1,500 people who get there, who want to buy them at the same time. Whoever gets there first gets to buy the ticket first. Whoever gets there last gets to buy the ticket last. Think about like if you're in line at Portillo's or something. I don't know if you've heard of Portillo's. It's a fast food place. Whoever's in line first gets to order first, and who's in the line at the end gets to order last. So a queue, basically, not all queues do this, but you can actually do. This is kind of actually misleading. And AJ, I'm sorry if you made these slides. This is kind of misleading because a queue can be implemented using a linked list or an array, but it's a lot easier using a linked list. And in a linked list, you don't always have a back and a front pointer. It's a lot easier if you do because it's constant time to access those. But you could just have the head of a linked list, and then you could easily traverse all the way back to the end to add someone into the queue. But that would take a lot more time, right? You have to traverse the whole linked list, so that's no good. So if there's a queue with a front and back pointer, that makes it a lot easier to do operations. But just remember, if you enqueue something, it goes in the back, and if you dequeue something, it comes out the front. Does that make sense? Just think of it just like you're in line somewhere. That's the easiest way to remember it. You're in line for fast food or to check out somewhere. So again, the runtime benefits, if this is again only mainly for the linked list implementation, and you have the front and back pointers. So if you're enqueuing, you just easily insert to the back. That's constant time because you know where it is. Same with dequeuing, you know it's at the front. Now, if you have to traverse, like I said, if the rear didn't exist and the front didn't, like they exist, but like they weren't, you don't have pointers to them, you'd have to go into the head of this list and go all the way back and back and back and traverse the whole list, which is end time. So I guess in a way, you could just say front is the head as well. It doesn't matter. So, any questions on that? All right. So, functions. Basically, here's the code. I'll let you guys quickly look at it while I'm talking. So, when you're enqueuing, basically, and again, this is for the linked list implementation. Basically, for an enqueue, think of it like you're adding something to the head of a linked list, except, wait. Yeah, think of it as if you're adding something sort of to like the front of the linked list. Basically, what you have to do, you grab the back pointer. Always, every time you do that, you're making something new. You have to make a new node, of course. But basically, all you do, you check if the queue is empty first. That's the edge case. Because if the queue's empty, the front's going to become the rear as well temporarily until something else gets added. But otherwise, all you do with your new node, you just have the current rear point to the new node, and then the rear point to itself as well. Basically, the old rear will point to the new rear, and then we're assigning the rear to the new rear as well. Does that make sense? Yeah, right now I'm just talking about enqueuing. Yes, this is wrong as well. Well, in this case, it depends. Like usually, yes, a DQ would return a given queue, but you might have it like I'm just making this up. Like if you're in line at Portillo's, for example, and you order, you don't really need to. Well, I mean, it is weird now that I think about it. But sometimes I guess in some applications you don't need to return it. You just want to say, okay, I'm just you know what a good example of this is? If you're at line in Portillo's and then you're like, okay, you know what? I'm leaving. They're taking forever. So you don't need to take them out, but I just want to DQ them so the next person gets ahead. So then you wouldn't return anything Brady. But yes, that's a good question. Usually it returns the front node. But anyway, all you do to DQ, first you just check if it's empty, because if it is, there's nothing there. You return null. Otherwise, though, you grab the current front, update the front to be that current front's next, and then if it becomes empty, you just check the rear to be, you make the rear empty as well, and then free temp. Does that make sense? Any questions? Let me ponder over that for a minute. Here, I'll set one of those stupid timers again. Yeah, let's do 30 seconds. Quick breather. I'll let you guys look at that. Oh, I can change the sound. Ooh. Let's try Las Vegas. That sounds interesting. Was it going to sound like we won a slot machine or something? That'd be fun. Wouldn't it be cool if you finished the foundation exam, if you passed, they like played a slot machine animation that you won? That'd be funny. Okay, that was stupid. That was a weird sound. Okay, let's move on. That's besides the point. So that's linked list. Not necessarily. Oh wait, are you talking about NQing or DQing, Sebastian? No worries. So now, okay, maybe the slides were messed up, AJ. I didn't see there was an array slide, so that's why I was talking about them together. So I kind of already talked about array-based queues. You can do them that way as well. But yes, they're very disgusting, but it's possible you might see one, and in fact, we're going to do one that's an array-based queue. So there's still constant operations, but you have to store, in addition to the front and back, the number of elements and the size. If you're NQing, you have to check if the number of elements is less than the size, then you could put it in. But then this is with something called a circular queue, because, for example, if you took out these two I can't use red, not red, stupid. If you took out these two elements, once you hit 7 and you need to NQ something else, you got to tell it to go back to the beginning. That's a circular queue. You just use the same spot over and over again, looping over. It's basically if you have space, you add the new element into this index of front plus number of elements mod size. It's just a formula. That's all it is. And then you increment the number of elements. Pretty easy. You just got to get used to it. Otherwise, if you're dequeuing, you decrement the number of elements, take out the thing at the current front index, and then update the front to be front plus 1 mod the size, and then return the thing you took out. Size is different than capacity. Wait, hold on. This should be capacity. These should be size. Size is how many things you have in the queue. Capacity is how many things the queue can hold. So in this example here, the size would be 7, but the queue capacity is 8. Does that make sense? Good catch, Kane. Any questions? Does that make sense what I just said? Me, actually. Well, I guess technically too, size, because if you think about it, size in this case is capacity. Now that I think about it, that's right. It's been a while since I've done circular queues. Size is the capacity. Number of elements is how many. It's weird. I would call this capacity and this size. Number of elements is how many things you have in the queue, and size is how big the queue can be. So size in this case is 8, and the number of elements is 7. Does that make sense? Yes, it would only go back over to 0 if you're trying to NQ. So if you had this in here, you had a 10 again. you couldn't put anything in unless you reallocated this array. But then if you took out at the front's here, if you took out this 10, then that space is available for the next thing to be put in. Circular cubes are weird. So, okay, sorry if that was confusing. Any other questions? All right, so should we do... Want to do a lengthless queue or an array queue first? Really? I was not expecting more people to say array. Okay, that's fine. All right. So, here we go. This is not going to be fun. This is probably the question I hate the most on today's material. Suppose we wish to implement a queue using an array. The structure is shown below. We're given a queue structure. Here's the array, the number of elements that are in a queue, front, and capacity, which it says here. The queue contains the array and three attributes: the current number of elements in the array, the current front in the queue, and the maximum capacity. Elements may be added to the queue not just at the end of the array, but also at indices in the beginning of the array before the front. Such a queue is called a circular queue. Which, and again, for a circular queue, you don't really need the back because you can use that formula thing. Write a function to implement a dequeue functionality for this queue, while ensuring that there are no null pointer errors that occur. Your function should take in one parameter, a pointer to the queue. Your function should return the integer that was dequeued. If the queue is null, or there are no elements to dequeue, your function should return 0. Okay. So basically, we just have to write a dequeue, which is pretty similar to what we said here. But now, in fact, I'm going to copy this. I think this might be helpful to have. This is almost like a procedure thing that I like to say. Come on, let me paste something else. There we go. But you also need to take care of the two edge cases. But nicely enough, in this question, it's given to you what the edge cases are. I think he's being nice because it's a circular cube. So let's take care of the two edge cases first. Let's check if the queue is null. So if the queue is null, how would I see if the queue is null, given the parameters we're given? Yes, you can do that, what Chris said. You could do the two edge cases together, yes. But you could also do them separately. In fact, let's do them together. I think that's better. So if Q, now, I mean, it helps to know, like, the DQ function, like, are you talking about this, Musana, up here? When you mean, like, remember the DQ function? Is that what you mean, the purple stuff? I'm confused. Oh, this? Yeah, the previous one was for a linked list. Wait, no, this up here? I'm confused. This? Yeah, I mean, you need to know the general idea because he's not going to tell you here, oh, you need to increment it by front plus number. Yeah, you need to know both, basically. He's just being nice here to say, make sure he's basically telling you don't forget your edge cases, which probably should be mentioned here, honestly, in my opinion. But yeah, both are important. But let's just take care of the edge cases first, because that's the most important. Everyone okay with that? All right. So if now, how would I check if the queue is null? In fact, I shouldn't even been there earlier. Now, let's just put these both together. That's one way of doing it. Sure, you can do like this, but for simplicity's sake, I'm gonna just do it normally. if Q is equal to null, that's one edge case. Now the other edge case we were given, if there are no elements to DQ. So I'd say or. Now how would I check if there's no elements to DQ? Be careful. You both are technically correct, but you need to use what's given in the scope of the question. There you go, Zishan. That's correct. You have to use Q because that's terrible Q. I can like not write Q's. My apologies. So you have to use the Q, letter Q, because that's the Q, what the Q name is. QQ, whatever. And then you have to use num elements because that's what it's called in the struct. So Q arrow num underscore elements is equal to 0. If that's the case, what am I going to return? Well, as the thing said, just return 0. Return 0. So doing all of that is 3 out of the 10 points right there. Now, let me ask you this. Could you flip these? I have one no. Could you flip these? You have a 50-50 chance, so I want to see how many people we can get to answer this one here. Okay, it seems like it's about 50-50. You cannot flip these here. It has to be in this order. If you nest things like this, if you said Q num elements was, if you check this first and the Q is null, it's going to crash. That will cause a seg fault because there's nothing initialized. It'd be checking, hey, is garbage number of elements equal to 0? It doesn't know. It's garbage. You have to check if the Q is actually initialized first, which this would take care of first. Does that make sense? No, that's like one of the very few things that like really stuck with me when I took CS1. You ever have that in class where like the professor says like one like little sentence that doesn't seem really important, but then it's just like the one thing that you just remember the most? That's one of those things that happened for me when I took CS1. Okay. So now what we need to do, we know there's a queue that exists, and we know that there's at least one element in the queue. So now we need to get that Q value. So I'll just say int front val. Now, if I want to get the front's value, how would I access that using the scope of the question? I want to see if I get a couple more responses. Okay, you all have the right idea, but Chris has the correct answer because you have to tell the code, okay, I want to use the Qs that were given. I want to access its array. I have to dereference it. I want its array, but I want to take it out at element Q's front. So I have to dereference that as well. Does that make sense? Any confusion on that? Sure. So remember, this is an array. And let's just say its capacity is 5. And let's say this is the front here. So we know, okay, I'm using Q and I want to access its array. But you have to give it an index, right? Because it's an array. You can't just say at front because there's nothing passed in that's called front. You have to say, okay, because it's in within that queue. So you have to call Q again and tell it now I want to access it from Q's front. Does that make sense? Yeah, what Sebastian said too. That's another way of saying it. Okay, so now we've taken out the front value. So now we have to update the front, right? We honestly we can do either of these, top and bottom, in either order. It doesn't really matter. So let's decrement the number of elements. So if I want to decrement the number of elements, how would I do that? Using the scope of the question. This shouldn't be too bad. Exactly. Q number of elements minus minus. And again, we're using the variable names that are in the structure. Is that this should be pretty self-explanatory. I'm just telling it, okay, there's one less element. Now, how would wait, does that make sense what I just did? Getting ahead of myself. Any questions on that? Okay. Now, how would I update the front? Using, because here's the, remember, it doesn't matter because you do it by the, does that matter? Wait, hold on. You might be right, actually. Yeah, you're right. You do have to do that first. Duh. Because you have to do it based on the original number of elements. Then my apologies. Okay, that has to be second. Sorry about that. Okay, so now, if I want to update the front, how would I do that using the scope of the question? You got it. So Q, arrow, front. So the front of the Q is going to equal, you increment the front by 1, but to ensure, so it'd be Q front plus 1, go to the next spot. But in case you're at the end now, you have to modify the capacity, the size of the Q. So in this case, because it's called capacity, Q arrow capacity. Does that make sense? Okay. Now and then you decrement the number of elements by 1. So now what's the last thing we have to do? We're modding because we're just following the formula here. That's just how circular queues work. Yes, we return the front value that we took out. Return front val. That's it. So does that make sense? Any questions? We have to decrement the number of elements because we took something out of the queue. Yes. The only other 5-pointer we're doing, I think, is a recursion question. And the only other 5-pointer we've done so far is the linked list question. That was tracing. Yeah. So DQ is this. You increment the front by 1 and then mod it by the capacity of the queue. It just works. Just don't forget it. You can't. I thought you couldn't. I think you say your name Natalie. Apologies if I pronounced that wrong. But you can't do it beforehand because the formula is dependent on the original number of elements. That's why you can't do it beforehand. I completely forgot about that until right now. So, okay. Yeah, there's one more 5-point question, right? Yeah, there's one more 5-point question. You know what? You guys are right. It doesn't matter. I'm so sorry. I've had a really long day. Yeah, it doesn't. Of course it doesn't matter because the capacity number of elements are different. Okay, forget everything I just said. The order of these two things does not matter. You can do this first. You could flip those two. My apologies. I'm so sorry about that. Thank you for clarifying that. So you guys are smart. You guys got this. Okay, one more Q question. Also, one thing I do want to mention, and I forgot to mention at the start, make sure that as you're practicing this, that you're actually practicing it like you're on the exam. Do it on paper and time yourself. Like give yourself 2 hours. I mean, obviously, if you don't finish in 2 hours, no one's going to take the exam from you, but then you'll know how you're doing timing wise. Like literally practice this exam like you're on the real thing, like you're on Squid Game almost, and like if you don't finish it, something's going to happen to you. Nothing will actually happen to you, but as you're practicing it at home, yes, you can do. Of course, no one's going to stop you. No one's going to run in, break into your house and take it from you. But on the actual exam, no. Yes, it's just a go away. Like as you're studying, be like, okay, I took this long. I took like 30 minutes extra. Let me see how I did better. How I can do better. The only way you get extra time on this exam is if you have SAS accommodations. So, all right, let's do the linked list question. Then we'll do some stacks. Then I think it'll be pretty easy for the rest of this session. So, and again, I apologize. We're definitely gonna go over 7:30. No matter what, though, we'll be done in about 90 minutes because then we're out of Zoom's gonna boot everyone off this meeting. I didn't realize that UCF will get a 4 hour limit time. So we'll be done by then. All right. So question number 2 for Q's. Oh, that was you. Okay, no worries. I think 4 hours is long enough for anybody anyway, AJ, so don't worry about it. Okay. Another Q question. We're now doing linked list. A regular queue only supports adding an item into the back slash tail of the queue and removing an item at the front slash head of the queue. A common method of implementing a queue is a linked list with pointers to both the front slash head and back slash tail of the list. If this method is used, as I've said, it's relatively easy to add the functionality of adding an item to the front and removing an item from the back. Given below is a partial implementation of this data structure, commonly called a DQ. Excuse me. Fill in the function that adds an item to the front. You may call the make node function, and you may assume that my DQ points to a DQ that exists, though it may or may not be empty. Okay, this is a little tricky. So if this is a queue, let's say we had a queue A, B, C, E, or up a D, keep it alphabetical. So A is the front and D is the tail. This is not normal. You'd add it to D, right? You just got to be careful what the question's asking you. Look what it's saying. Fill in the function that adds an item to the front of the queue. It's like not what you're expecting. So if I want to add an E, I want now A to point to E. This is like the kind of fun Guha likes to have on the exam. Does that make sense what we need to do here? Basically, we're just NQing, except we're putting it at the front and not the back. Does that make sense? Okay. So, this honestly isn't too bad, but we need to be careful. Yeah, basically, this is gonna be a stupid analogy. Basically, you're in line at McDonald's for food, and then I don't know, who's someone famous? Taylor Swift walks in, so everyone, of course, lets Taylor Swift order before them because they love her. So basically, someone skipped to the front. So let's write out a procedure for. I know it's a stupid example. Let's write out a procedure for this one. I think this one would be a good procedure question. So what's step 1 if we want to add something to a queue? Any queue. Yeah, it's sort of like a priority queue, like in the emergency room. We were told somewhere. Well, it doesn't matter if the queue is null or not because we're adding something to the front. So we don't need to really check that yet. We have to make the node. Exactly. We have to create a node. We can't put something in a queue with nodes if there's no node. So make a new node. That's step one. Step mm, step two. What do you think step two is going to be? Someone already said it. Check if the front is null. Exactly. Because what if the front is null? What does that mean? It's an empty queue, which means what? Well, yes, if the queue's empty, though, like when I'm saying, with this new node, what do we have to do specifically? Another, so someone's going to say this again. Chris has it right again. Someone's probably going to say Chris, another W. You have to set the new node not only to the front, but also the back. Does that make sense? Okay. So basically, check if the front's null. Front's null. If it is, if it is, I'll just do this for simplicity. Front also equals the back. Otherwise, it's not. So then what do we do? If it's not, what do we do? Then we just put it in, make it. Well, not only do we make it the new front, we have to update the pointer too, that from the current front, right? Or from the new node so that it doesn't, we have to basically make sure E still has access to A. We don't want to lose everything else. So I'll just say update pointers. All right, is everyone okay with this? This one's pretty quick. All right, so let's make the new node. Now, conveniently, if you actually take a minute and look at the question, isn't that handy? We can just call that function. So I'll say node. Now I'm using node because that's what the node structure is called. Node pointer, and I'll say, let's call it new. And now I'm going to call make node. And then I'm going to pass in the new value, which is called val, and that's passed into the function. Val. Everyone okay with that? That right there is two of the points. That's a fifth of the points in this question. Isn't that crazy? Okay, so now let's do 2A. So how would I check if the queue is null or not, if the front is null or not, using the scope of the variables given in this question? See if we can get one or two more. They're both, yes, you're both correct. You write it either way. You can do the exclamation point, the logical not, or you can just say if it's equal. Whoops, I just dropped my stylus. If it's equal to null. Just for simplicity's sake, I think it's a lot easier to do it the equals equals way. So if, no, you can't check I, I wouldn't check the rear since we're adding to the front. I guess technically you could, but just deal with the front in this case. I think it's just a lot easier that way. So if my DQ, since that's the queue that was passed into the function, if my DQ dot or arrow, arrow, good. Arrow front, if that's equal to null, what am I going to do? We're going to also, we're basically that the new node becomes the front and the back node becomes the front, right? That's what we said. So, you know what? I'm going to copy this because I am lazy. My DQ, maybe not. Forgot. I can't do that. Oh, maybe I can. There we go. My DQ front is going to equal the new node we just made. So new. And then the same thing, the back is also going to be new. So front will have back, and that equals new. Everyone okay with that? What I did there. So that was step 2A. I forgot to check these off. So we did 1, we just did 2A. I don't think I don't know if C supports doing it on one line or not. That's something you could Google on the internet. By the way, I like how your username's Pointer. Um, Google that. If I don't know if that's legal or not in C. I know it is in Java. I don't know about C. That's a good question. I'm guessing it is, but I have no idea. Otherwise, what are we going to do? We're going to do 2B. We just have to update the pointers. So basically, what I want to, if we're doing this and we ease the new node, do I want to make the front equal to, do I want to make E the front first, or do I want to have E point to A first? You have to have E point to A first, because if you don't, you're going to lose access to all this. So how would I have E point to A first, basically? How would I have the new node point to the current front? Using what's given in the problem. You got it. News next is going to equal my DQ front. New arrow next is equal to my. Telling you, if someone's counting how many times I did this, you'll have a lot of nickels. I cannot spell Q. Q-U-E. Arrow front. And then how would I make our new node the front? Yeah, my DQ's front is now equal to the new node. My DQ arrow front, that was a terrible F, whatever, equals new. Essentially completing what we did. And this is a good one you can check, see if it works. So, like on this example here, we made E. So is the current front A null? No. So I'm going to have E point to A. So technically it'll be this. It's just weird. And then my DQ front is the new node. So this is the front now. And it works. So you did it right. Always good if you can. Check it on an example or two. See if it works. So everyone okay with this? A would, just because we're inserting into the front, technically, it's a very weird problem, Sebastian. That's why. It's very weird. Because normally you insert into the back. But this is what you need to do. Yeah, see, honestly, summer 2023 and confusing wording, you know what that equals? That equals one person who wrote this question. You want to take a guess? And no, it's not Guha. Mm-hmm. It was Mead. Mead probably wrote this question. Yeah, because I was told actually, Guha told me this fun fact for you all. Quick break before we move on to the next thing. There's just a different way of doing it. It's slightly different. But before we move on to the next topic, what actually happens is so the four sections, Guha will always write one of them, but then like the other three, he gives other professors to write the questions. So like Ahmed will get a section usually, and like Steinberg might get a section, and like someone else, like I don't know, Kalu or somebody, I don't know, will get the next section, and then they'll bring their questions back. But then since Guha basically runs everything, if he doesn't like one of their questions, he'll write his own. Isn't that interesting? So there's a little fun fact for you all. It is crazy, but I mean, in hindsight, it makes sense. A little variety. So, okay, let's keep going. Stacks. All right, we got 90 minutes left. Oh, hey, Tony. I didn't see you there. All right, what are stacks? It's exactly the same thing as a queue, basically, except it's the last thing in is the first thing out. So think of it like a stack of plates. You put something in on the top of the stack, it's called pushing. It's constant time. And you take something out of the top of the stack, it's also constant time, and it's called popping. Applications are include infix to postfix, which we'll do an infix to postfix. We won't do a postfix evaluation because I specifically wanted to do a coding problem on this one. Sorry. Maybe if we have time at the end and you guys really want to do one, we could do one. Backtracking CS2 topic, so don't worry about it for this. Syntax parsing, so like recursion uses stacks and valid parentheses. So basically, if you think about it, a stack is a queue, except there's just everything gets inserted and taken out at the front, and there's no back. That's another way of thinking about it. Does that make sense? All right. Usually use an array. So if you're pushing into array, you just increment the top by one, aka the front, whatever the hell you want to call it, and then just increment and then just put it in the new element at that new top value. Like you could put this here and then just have this say top. Both are correct. Or you could, or I'm sorry, then for popping, you have to do in this order. You take out the item from the top in the array, and then decrement the top and return the item. Does that make sense? It's pretty self-explanatory. Cool. Um, yeah, I don't think that does not mention there. Quick question. Could someone tell me what a stack overflow error is? Just curious. Exactly. If you go past, let's say a stack only can hold 10 elements, and you try to push an 11th element in, it doesn't have room. So it's called a stack overflow error. Or it might say stack smashing, one of the two. So just something to keep in the back of your head. And that's where the website Stack Overflow got its name. Fun fact. Okay, anyway, infix the postfix. You see this a lot. Oh my, for a split second, I thought that was my handwriting from an old question. I was like, what the hell? That looked like my handwriting for a second. It's not. So infix the postfix is converting something that we can read in order of operations, like this, but a computer cannot know that. So we have to convert it to a value, something called a postfix expression, which a computer can easily read. But both of them will evaluate to the value 13. Now, one thing to be careful of, remember, there's different priorities. And actually, I need to check one thing really quick, just so I don't give you guys the wrong information. I'm pretty sure I remember this. There's just some things that I don't remember, like the quick details of because of what's it called? Because I haven't taken the class in a while, and it's not as important as some of the other stuff. But give me 30 seconds. Okay, that's what I thought. One thing that is not mentioned here, which you don't really see that often, but you need to mention, and I'll get into this prior to 70 seconds. Just remember, Modulus, think of it like division. Modulus has the same priority as multiplication and division. So remember, infix to postfix is converting an expression like this that we can read into an expression a computer can read. So you go from left to right in the infix expression. If you see a number or a letter, if you see anything that's like not an operator, so if you see anything like that's not those, put it immediately on your postfix expression. Otherwise, if you see something like this, you put it onto the stack. Unless you also could put a parenthesis into the stack as well, a left parenthesis. So let's just say you see an operator. If the item, basically you take the operator you see and take it in your hand. If it has a higher priority than the thing at the top of the stack, you push it to the top of the stack, the one in your hand. Otherwise, you keep popping items in the stack until the thing you have in your hand has the biggest priority. Does that make sense? So that's how operators work. Any confusion with that? Okay. And then if there's a parenthesis, yes. This will make it'll just make a lot more sense with an example, honestly. I think it'll make a lot more sense just doing an example when we do the one question. Because that's literally all it is. And then if there's a parenthesis, the rule is you treat them as nothing. They're kind of like a blocker. So if you see a left parenthesis, you push into the stack, and then once you see a right parenthesis, you just pop everything to the left parenthesis. We'll do the example. It'll make a lot more sense. And then postfix evaluation is basically the opposite. You basically put numbers into a stack. Here's an example. And then once you increment an operator, so like multiplication, minus, subtraction, or I just said the same thing twice. Multiplication, minus, plus, mod, whatever. You just do that on the top two values in the stack and then push them back in. And then whatever's left in the stack at the end is the answer. If we have time, I'll try to move fast enough so we have time to do a quick postfix evaluation at the end. But more than often you see infix to postfix. So, but I also want to do this coding question because I really think this is a good question here. But let's do the infix to postfix first, I say. So, are we ready for this? This is just getting the procedure down. And once you get the procedure down, it's smooth sailing. So we'll come back to this in a minute. Okay. Convert, and please, for the love of God, I cannot tell you, there's been a couple times I've done this and I've seen students do this. They'll start doing postfix evaluation and it's infix to postfix or vice versa. Please read the question 2 or 3 times and make sure you're doing the right type of operation with the stacks. I would hate for you to do the whole thing and then realize you did it incorrectly. So, okay. Again, this is just following a procedure. So here we go. Actually, hey Jay, sorry I'm calling you out here, but you forgot to paste in the stack themselves into the solution. Let me get that super quickly so I make sure I don't give you guys the wrong, because filling these out is like 2 points each. In addition to the final answer. Because you have to show your work in these steps. This was spring 2024, so that's going to be here. Oh, this is the same exam from that triangular sum question I did. This is it, right? Okay. All right, here we go. So, you start from left to right. Is 3 an operator or an operand? Operand. It's not a symbol. It's a number, basically. Operands are numbers. So if it's an operand, what do I do? You put it straight on the postfix expression, no questions asked. So we have a 3. And then what I'm going to do is cross it out, just so I don't get lost. Now we have a plus. So it's an operator. So I'm going to take it in my hand. What priority does a plus have? 1, 2, or 3? And remember, the higher the number, the more priority it has. The least power. But is there anything in the stack right now? No. So can I put it in? Yeah, of course I can. No problems there. Okay, So we're done with the plus. 1, operand, put it straight on the postfix. No questions asked. Okay, minus. Take it in my hand. What is the priority of the minus? 1, 2, or 3? 1. It's the same as plus. So based on the rule, what you do, you cannot, I repeat, cannot just put it in. You have to pop anything in the stack, everything in the stack until the thing in your hand, in this case the minus, has the highest priority. And whatever you pop, you put in the postfix expression. So in this case, I'm going to pop the plus, put it in the postfix expression. Now the minus has the highest priority. So now I'm going to put in the minus. Does that make sense to those who were confused on that a minute ago? Is there any confusion on why I just did what I did? Um, that's just how it is. I don't know the reasoning why that's how it is. That's just the way it works. There's probably someone who could tell you that. But operator, what do you mean operators on the side, Sebastian? Like the priority list? No, no, no. You need to. So yeah, it would be helpful probably, like because I'm on an iPad, so this is a lot easier. But like on the exam, I would like be doing all this on like a stack on the side. Like, make your own, because you only want to have what your final answer is in here. Because then once you hit this letter A, that should not change. But since I'm doing it on the iPad, it's just a lot easier. But it'd be helpful on the end, on the side, to like have your own stack and be doing everything in there. Then you just cross it out and do whatever the hell you want with it. Does that make sense? Okay. Okay, so now let's keep going. We did the minus. 7, postfix, no questions asked. Oh, and by the way, this question has exactly the correct number of boxes. Some of them do, some of them don't. You just got to pay attention to that. Okay. Star. What's the priority of star? 2. Can I put it into the stack? Yes, because the star, the thing in your hand, the star, has a higher priority than the thing or the item at the top of the stack, which is the minus. 2 is greater than 1. So I can put it in, no questions asked. Does that make sense to everybody? So the B and C stack, so see how we've hit this letter A? Now we've done everything up to part A. So now you copy over what you've done and you keep going. And then once you hit, basically, these are just to see if you're on the right track all the way, because they can give you partial credit there. So now we'll do some more stuff with the stack, and once we hit B, whatever we've done in all of this will be in B. Does that make sense? Gotcha. But okay, did the priority thing make sense to everybody though? Okay, cool. Okay, so now we're going to keep going. You just bring over what you have. All right. Left parenthesis. Left parentheses, just think of them as like the most superior. No matter what, just put them in the stack. No questions asked. They're weird. And then cross it out. Okay, 4. Put in the postfix, right? It's a number. No questions asked. Now, parentheses are cool. Now, if the parenthesis wasn't there, would I have to pop it? Would I have to pop anything? And if I do, what would I have to pop? You'd have to pop the star and put the slash in. But because of the parenthesis is like a barrier. It cancels everything out. Well, I shouldn't say cancels everything out, but it excludes everything below it. So now, whenever there's a left parenthesis, anything you put above it, right, immediately above it, has the highest priority right now. So you can put in this divide, no problem. Does that make sense? Okay. So we did the slash. 2, put in the postfix, no problem. Plus, can I put it in right now? No. So what am I going to pop? You just pop the slash. The left parenthesis acts as a barrier. So I'm going to pop the slash, put it in the postfix, and now put in the plus. We okay with that? Okay. 5, postfix, no questions asked. Okay, right parenthesis. Whenever you encounter a right parenthesis, no. Whenever you encounter a right parenthesis, you just pop everything in the stack until you hit a left parenthesis. And then you take out the left parenthesis as well. So in this case, there's just the plus. So you put that on the postfix and then get rid of both of these in this case. Does that make sense? I'll assume that's a yes. Okay. And now we did that. Okay, now we have, yeah, I canceled it basically. Now we have another multiplication. Can I put it into the stack right now? Visually, nothing's going to change in the stack. But technically, because both the stars have the same priority, I need to take out the one in the stack, put it on the postfix, and then I would take this new one and put it into the stack. But visually, that looks the exact same. Now, 8, we're going to put it straight onto our postfix. No questions asked. Subtraction. What, if anything, what am I going to pop? I have to pop both the star and the minus. Good. Because you have to keep popping everything until the thing in your hand, in this case the minus, has the highest priority. So the star would go first because that's at the top, then the minus. So then these would both go away. And now we're going to bring this new minus in. And now we're done with that. 7. Put under the postfix. Slash. Can I put it in? I have 1 yes. Yeah, push it, no problem, because it has the highest priority. Left parenthesis, don't ask anything, put it in. 5, put it on the postfix. Minus. Can I put the minus into the stack? Yes, good. Because again, the parentheses is a barrier. Okay, now we've hit the letter B. So now we're done using this middle. Oops, I don't want to. Whoa, what the hell did I just do? Wrong button. Now we can take all this, and now we're going to move on to C, because as you can see up here, that's B. And in case you couldn't tell, that's where B is. It's kind of indicated down here. So, all right, let's keep going. Normal sum. 3. Put it straight in the postfix. No problem. Plus. Can I put that into the stack, or is there anything I need to pop? You have to pop the minus because it has the same priority. So this becomes a plus, and the minus goes down here. Okay, left parenthesis, throw it on in there. 5, put it right onto your postfix because it's a number. Okay. Plus, can I put that one into the stack? Yeah, of course you can, no problem. Because of the parenthesis. 7 goes straight to your postfix. Oops. Okay, right parenthesis. What am I going to pop now? Is it just the plus, or is there anything else? Also got to do the left parenthesis. Don't forget that. But the left parenthesis doesn't go on your postfix. One thing I should point out too. If you're doing an infix to postfix question, your postfix expression should never have any parentheses. If you have a parenthesis somewhere down here at the end, you did something wrong. Postfix should never have a parenthesis. Anyway, so let's keep going. Divide. Can I put that into the stack? Yeah, No problem. Push it on in. So now we've done that. Now we've hit C. Now you might think to yourself, yay, we're done. No, you're not. You have to finish the whole expression. This, again, these are just partial credit at certain spots. So you need to bring everything over to the side and keep going in your working stack. So now let's finish it. Left parenthesis, put it in. 3, postfix. Multiplication, can it go in? Yeah, push it in. Get rid of that. Why did I go down there? I don't know why I went down there. Okay, 2, postfix. Okay, right parenthesis. What am I going to pop? The star and the left parenthesis. There's 2 of them, so you only go to the first one. See, there's 2. You just take care of this one. So now I'm going to pop the star and then get rid of both of those. Now we have another parenthesis. So now what am I going to pop? Yes, those 3 things. But the parenthesis doesn't go down here. Okay. Now you've hit the end of the expression. But remember, oh, I didn't get rid of the parenthesis, my bad. But remember, anything in the stack at the end, you have to pop everything in the stack independent of the postfix at the end. So in this case, get rid of the slash and the minus. And that, my friends, is the final answer and the correct answer. Do you mean the postfix evaluation, Jacob? I'll try to hurry with the other stuff. I want to spend some time on the coding question here, but if we have the recursion should hopefully not take too long. So we have time at the end. I'll do one of those really fast if that's okay with everybody. All right, let's keep moving then. So any quick questions before we move on? Okay, and then you can see that here. Okay, now there was originally a postfix evaluation here, but I wanted you guys, I don't know if suffer is the right word, but I want you to experience what I had to go through in my foundation exam. I didn't get this kind of question I was hoping for. Yeah, there's one there too, or you can look on your old professors. But anyway, I was very surprised. You ready to see the question I got for stacks? It's a very good question though. But when I first saw this question, I like freaked out. I was like, "Oh my God, what the hell?" Are you ready for this, everybody? Get ready because it's literally an entire page of just the question. It's not even half and half. Boom. I saw this on the exam and I'm like, what in the hell is this? I promise this is not as bad as it seems. I know it's disgusting. It's very disgusting. But I think it's a really good question. I really do. Because you don't really do much stack coding questions in class or really anywhere. So it's possible you might see one. And so I think this is a good one. And if you were on my little study session the other day, we did this question, but I apologize. I'm doing this again. But this is one of my favorite questions, honestly, just because I think it's a really, because just you don't do stack coding that much. So, all right, let's get this stupid thing over with. This one, by far, by the way, this was the one question I would not have been able to do without doing like my own procedure thing. And you'll see why. Okay, here we go. 10 points. You are playing a scoring game that uses a last in, first out, hint, hint, stack approach for keeping track of scores. Here are how the scores are managed. You are given a character array, also known as a string, of moves, where each index represents some rule for managing the score. You must go through the array in index, basically from left to right, order to properly manage the score. Here are some rules, or here are the rules for managing the score. If the move is some character representing an integer, so 0 to 9, just record that integer itself. If the move is the character plus, you will need to retrieve the last two scores recorded and compute the sum. After computing the sum, you will need to add this sum to the recorded list of scores. Once all the moves have been processed, you will need to compute the total sum of all of the scores and return this value. Okay, what in the hell is this asking you to do? Here's an example. I guess, yeah, it technically is sort of postfix evaluation, except you're only adding. Sort of. Yeah, good point, Sebastian. Never thought of that. Yeah, you're right. It's just you're only adding. Anyway, so here we go. For example, if the string passed to the function is this 2, 5 plus 3 plus 1, then after processing the first plus sign, the corresponding stack of values from bottom to top would be 2, 5, 7. I don't like the way he wrote that. Look, think of it like this. It's a lot easier this way. Think of it the normal way. Here's 2, 5, 7. Why is it that? Because you hit the first plus sign, and then you pop 5 and 2, get their sum, which is 7, then pop them or push those two back in where they came from, and then push in the 7. Does that make sense? It is postfix evaluation. Does that make sense so far to everybody? Okay. Now, after processing the second plus sign, you're adding in 3 and 10. It just keeps going. Then doing the string completely, the stack is this. I don't feel like reading it out. Then once you're done, you get the sum. You pop everything in the stack and 41, which is 41 in this case. Complete the following function definition that simulates this game. You may assume that the string.h library is included. The provided functions and stack structure are here to assist you with completing this function. Note, there exists a solution that doesn't use a stack, and this or any such solution will get full credit if and only if correctly implemented. For simplicity's sake, let's just use the freaking stack. The parameter represents the character array of moves, the string of moves, and is guaranteed to be valid, meaning the string will only consist of digits and plus signs. And if there is a plus sign, you'll know they're guaranteed that there'll be at least two numbers before the first plus sign. Everyone okay with that? I know it's a lot. Are we ready for this? Any confusion on what we need to do? I don't see any responses, so I want to make sure we're all on the same page with this. Let me get more than one. Okay. So here's what we're given. We're given a node structure for some reason. And we're given a stack structure. And the stack, oh, that's why, because the stack has the topmost node. And then we're given some helper functions. This initializes a stack to be empty. This pushes an item onto a stack that you give it. This pops the item at the top of the stack. And then this tells you the stack is empty. Okay. How do you think we're going to approach this? This is where the procedure is going to be really, really helpful. What do you think step one is going to be? Give me some ideas. Let's do something else before even initializing the stack. Something with, yes, get the length of the string. It's a lot easier to deal with one single value than having to call string length multiple times. Plus, that's bad. That's not good standardization. For example, just real quick, if you're in a loop and you have something like this, and I is less than like the string length of something, whatever it is, that's not good because every time the loop iterates, it has to call string length over and over and over again. Where if you only have a constant value there, it's constant time, and it makes your code run a lot faster. Does that make sense to everybody? So anytime you get something like that, you always, if you think you have to loop and keep it less than a string length, always save the length first. So one, let's save the move length. Good job, Chris. Okay. Step two, then as you said, let's initialize it, create and initialize a stack. Because you can't do anything without a stack. Okay. So now what do you think we're going to do? Yes, we need to start looping. Because we have to do this for each character in the thing, in the string. So that's step three, loop. Okay. Now we have to be careful. There's two possible scenarios, right? What are the two possible scenarios? Think of the string. Yeah, plus or an integer. So let's take care of the sign. So there's two possible. I'll do 3a and 3b. 3a, if I'll just say the char. Let's do the sign if it's a plus sign first. If the char is a plus, what do I have to do? Well, you don't push right away, remember. What you have to do based on the question, you pop the two things at the top of the stack, the two top values, get their sum, and then push them back in. So you have to pop the top two values and save them. Remember to save them. Pop the top two values and save. Next, compute and save the sum. Now, here's something tricky. And this is also why I really like the procedure on this question. Let me go back to this example for a minute. Here's a stack. If I have 3 and 4, I pop it out. So I'm going to pop out. Let me do this. Int A is going to be the first thing, 4. Int B is going to be the second thing, 3. So right now the stack's empty after I pop those two. And I'll say int sum is 7. That's A plus B. What order? Well, tell me this. Does the order matter, you think, of pushing these back into the stack? Yes, it does. Because otherwise you might mess up the calculations further on. What order am I going to want to push these back into the stack? Be careful. No, yeah, that's right. Be a sum. Yes. Because you have to take the second thing first, because that needs to go on the bottom. Then you take the topmost original element, so 4 in this case, and then you put in the new sum, and then it'll keep going onward. Is everyone okay with that and why that order matters?
I understand why you're doing that. The only thing I don't understand is why are you putting A and B back in?
Because that's what the question told you to do.
Oh,
See here, you pop 2 and 5, and then you put them back into the stack after.
okay.
Right.
Okay.
This is just, something like this, you just got to read it a couple times. But good question. So then push, I'll just say in order. So that's if it's a plus, right? Because then we've taken care of the sign if it's a plus. Now 3b, oops, what if it's not a plus sign? If the char isn't a plus, what am I going to do? We said if it's not a plus, if it's an integer, basically. What do we say to do? Push it. Exactly. Push it. Now, here's an interesting question. Can you just push the character right into the stack? Or is there something you have to do first? I almost missed this on the exam. Mm-mm. Think about what we're going through. There you go. Chris has the answer. Oh, remember, this example input, the input's a string, but we need to do numbers at the end. We need to convert those to integer values. So we need to take the ASCII value of each number before we push it into the stack. Does that make sense? Basically, we're converting it from a character to an integer. Does that make sense? Exactly. You subtract by 0, yes. Yeah, it's very similar to what you do in a try. Push it. So you push it after uh indexing, basically. Does that make sense to everybody? Why that is? Any confusion with that? Okay. So then once we do that, we've processed the whole string, right? So then what's the last step? What's step 4? What did it say we had to do? No, Zishan. No, that's the ASCII index is not the same as its real number. I'll get to that in a minute. Yeah, you have to you pop everything in the stack and add them together. So pop a whole stack and get the sum, and then step 5 is return the sum. Do you see why on a question like this, that like this is like critical? It just makes it so much easier, in my opinion, just to go step by step like that. I don't know about you guys, but I don't know. Does that help anybody what I'm doing? Cool. All right. So now let's follow this procedure. So let's do step 1. Save the length of the moves. So int, I'll call it strlen. No, I don't want to do it. Int len equals strlen using string.h of moves. Okay, now we have the length of the string. Done with step 1. Step 2, we need to create and initialize a stack. So now looking at this, how would I create and initialize a stack? And do it in 1 line for me. Actually, no, you have to do this in 2 lines. Never mind, you have to do this in 2 lines. Any ideas? Using what we're given, how would I create and then initialize a stack? Remember, we're given some helper functions. Chris has it. Again, we're given a stack structure. So you can just declare one and then call the initialize function. It'll do all the malloking for us. Now, if you could do it with what Chris said, and then pass the address. But if you do it like that, every time you do everything else, you have to remember to pass in the address of the stack to all these other functions. So what I think is easier to do, and you can do this, just make the stack T, the original stack, I'll call it my stack. Make that a pointer. Because then after you do that, you never have to pass the address again. You don't even have to worry about it. Does that make sense to everybody? So now we initialize my stack using the provided function. You could do it the other way, but I just think this is easier. Okay, step 2 done. Because remember, Chris, if you do it the other way, each time if you call empty, pop, push, you have to remember to pass in the address. You maybe could, Sebastian, but let's just, I don't know. My brain's getting tired. We're running out of time. So now we're going to loop. Can I do a for or a while loop here? Yeah, we know how many times we're going to do this. For loop. For int I equals 0, I is less than len, because that's how many times I need to do this, I plus plus. Okay, so we're in 3. Now we got to do 3a. So let's take care of 3a first. If the character is a plus, so if what? How would I see if the current character from the string's a plus? Not string compare, because this is a single character, not a string. We're looking at a single character. Yeah, if moves at I equals the plus sign. If moves at I equals, and then single quote because it's a character. If that's true, then let's do what we said. So pop the first top 2 values and save them. So I'll just do what we did before. Int A equals pop of my stack. Int B equals pop. Damn it. No, do not do that again. Pop of my stack. And then I'll say int sum equals A plus B. Everyone okay with that so far? So now push it back in the correct order and remember what that was. The stack shouldn't be empty because we're guaranteed by the first time no matter what the first plus sign will hit, we'll guarantee there's 2 numbers before it. It said that in the question. Good question though. So now we got to push BA sum. So push, and again, I'm just using the functions that were given to us. My stack A, no, not A, B, and I'm just going to copy this twice. I'll change it in a second. Let me just copy these. No. Okay, so now we'll get A and then sum. So that is the entirety of step 3A. I'm not using the address for pop and push, Daniel, because when I declared the stack, I made it a pointer. That's why I made it a pointer, so I didn't have to think about that every other time I needed a function. If you didn't make this a pointer, then every time you called one of these functions, you'd have to pass in the address. I just did that to make it a lot easier because I remember when I took this, I'm like, I know I'm going to forget that somewhere. So it's personal preference. They're both correct. Okay. So now let's do 3B. If the character isn't a plus, we have to push it. So else we have to push with the stack with the current character, so moves at I, but we need to convert it to an integer value. Now, could someone tell me again, how do we convert a character to its integer value? Or let me say this again. Let me say, how do we convert a character that's 0 through 9 into the integer that's the same number? So we have the character 3. How do we convert that to the actual number 3? Yeah, you subtract it from, be careful here, the character 0. Okay, now, show of, well, it's hard to say show of hands on a Zoom call, but how many of you do not understand this? Why I have to do that? Like in a try. Anyone not understand that? Yes. Yes, Sebastian. Does anyone want me to explain why this is really quickly? I can cover that in 2 seconds. Okay. Uh, let me pull up really fast. ASCII. So in ASCII, this is just using ASCII chart. In ASCII, hold on 1 second. Or, oh, I did this correctly. There we go. Okay. So in ASCII, the array of numbers from 0 to 9. 1, 2, 3, 6, 8. It's a terrible array, but whatever. It's like an array of numbers, basically. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And in ASCII, these indices respectively are 48, 49, 50, 51, 52, 53, 54, 55, 56, and 57. So, and remember, these are characters in here, but I'm not going to put the closest. But since these are characters, if I want to convert the character 4 to the number 4, I take that character's index, 52, and subtract it from 0. And what's 52 minus 48? It's 4. So that will give you the actual integer value of 4. Does that make sense? It's just the convention. Okay, cool. All right, so with that out of the way, we've done step 3b, meaning we've now done step 3. Now, how am I going to finish this? How would I pop the whole stack? Well, let me close out this loop and the if statement. So now we have to just pop the whole stack and get a sum. So firstly, declare a sum and initialize it. Always remember to initialize your sums. And now, do you want to do a for loop here or a while loop? Be careful. Do we know how many times we need to pop the stack? We don't. We need to know, yeah, while the stack isn't emptied. So while, and so let's look at what it says. Returns 1 if and only if the stack pointed to by S is empty. So basically, while pop, no, I'm sorry, not pop, empty with my stack does not equal 1. What am I going to do? I'm going to pop the value and add it to my sum. So res plus equals pop of my stack. And then once that's over with, oh my God, that completes step 4. And lastly, we need to return the sum, or I called it res. So return res. And that, my friends, is the final answer. We did it. The procedure I told you is just really fucking important. Sorry again, I swore. Sorry, Anthony or AJ. The procedure is just really important on this. So yeah, I'm honestly gonna believe I did this on the spot either, Sebastian. I don't know how I did that day. I know I would make this 15 points too. So any questions on this? Hopefully, if you haven't experienced it now, you got Yeah, I can do that real quick, Barry. So here's an example. So let's say the two top values at the stack are 3 and 4. So I pop 4, save it to A, and then pop 3, save it to B. And then I compute the sum of those two. 7. So you have to keep the same order. Like you have to have 3 before 4 before 7, based on the question, and also because so then you don't mess up future calculations. So I have to put, if I want to keep the order, I have to put B back in first and then A, so I have the same order that was. And then once I do that, I put in the sum. Does that make sense, Barry? Okay, cool. Yeah, this was a very hard question, but very good practice, right? I think we can all agree on that. Very good practice. All right, let's finish this thing. Recursion. And these questions should not be too bad compared to what we've done. So, recursion. It's most easily identified as a function that calls itself, usually with different parameters. It's almost like a way of looping, but sometimes it's essential for more complex tasks where insertion or iteration lacks. So like binary tree operations, some linked lists, tries, and other trees like that. So, and it also uses the divide and conquer algorithms like merge sort and quick sort, as you know. So an example, basically when you're coding it, you need a base case, which is usually at the top of the function as an if statement, which can be followed by a return or simply wrapping up the bulk of the entire function. Basically, it just makes sure you don't keep going infinitely. But then if the base case isn't true, you just do a recursive call, which is just moving forward to the next one. Like the next incrementation. Everyone okay with that? I think your silence is a yes. Okay, cool. So then conceptually, you can draw all of these calls out as what's called a recursive tree. Trace a function out with each recursive call to itself being a branch. And then once you finish that recursive call at the end, you just work your way back up to the top, which is a common tracing problem on the Foundation exam. So tips that are here, the recursive call should be basically, I don't know, it's weird wording. Just move on until the next. Oh yeah, I get what it's saying. So like when you hit a recursive call, you don't finish what's there. You keep going and you immediately go to the next recursive call. And then as you're working your way back up in each separate recursive call, then you finish anything that's left over. Does that make sense to everybody? Okay, no problem. Okay, so I'll just show an example. So let's say this is a linked list. So let's say I have 3, 5, 8, and 7. So I'm calling the function with 3. Is head null? No. So I see a recursive call. So what I'm saying is I have to remember that there's still stuff left over from when I'm calling the function on 3. Does that make sense? But while I have that in the back of my head, I'm going to move forward now to 5. And then the base case is not true for 5. So then I move on to 7, remembering the 5 call also has to do this. Or I'm sorry, then 8. Then the same thing for 8, but then for 7. But then once I hit 7, the base case is true. So then I start working my way back. And as I go back from each recursive call, I finish anything that was below. So for 7, I have to freeze 7. So it goes away. Then I go back to 8, same thing. Then I go back to 5, same thing. Then I go back to 3, same thing. And the list is empty. Does that make sense, Sebastian and everyone else? Okay, cool. Here's some more examples and just the differences. I'll let you look at that in your own time. I want to get into these coding questions, which are not too bad. Oh, return value. Is that it after this? Yeah, okay. So sometimes it's used kind of like an accumulator function, where it's like you basically add on each recursive call, you add in the results of all the rest of the recursive calls, basically. It's very useful in like binary search trees and stuff, basically. So By the way, this recording probably is going to take a little while to process since it's 4 hours long at this point. But I'll let AJ know when it's out, and then yeah. Anyway, so actually, AJ, where are you going to post this recording? Because I can just throw it on. Okay, I might throw it on my YouTube channel too, unlisted. All right, so two coding questions. Here's your other 5-point question of the night. Hint, hint, it should be easy. Write a recursive function that, given an array, the length of the array, and a range of indices, finds the number of even integers in the array within that specific index range. Solutions that use a loop will receive 0 points. For example, if ARR stored 358, 679, and 411, 8, and the function call evens was with the array 9, so the length is 9 here in this array, starting at index 2, and then ending at index 6, so 3, 4, 5, at 4, the function should return 3, because the contents of index 2, 3, and 6 are all even numbers. Does that make sense? Does it make sense what we're being asked to do here? Okay, cool. Okay, so always easy enough, in my opinion. Start with the base case. What do you think the base case would be here? How do we know when we're done? Array should never be null. No. So if low index is greater than high index, yes, exactly. If low IND is greater than high IND, that means I'm out where I should be. So what am I going to return? Looking at the return type of the function. Return 0. Good. Return 0. Okay, cool. Otherwise, we need to make our recursive call. And this one's actually kind of like this accumulator thing. In fact, it is. So what would I want to return? We're going to do the recursive call and the current check in one. Let's do the recursive call first. What would the recursive call look like? Yeah, so basically what's the only thing that's changing on each as we're moving forward? The low index. And everything else remains the same. So it'd be evens of ARR. The array isn't changing, the length isn't changing. We're moving the low to the right one, so low IND plus 1, and then the high index. That's the recursive call. Now, how am I going to add in what the result of the current, um, if the current element is 0? Exactly. You check, hey, because remember, we're checking every time at the low index. So is the array at low index mod 2 equal to 0? Because if it is, that means it's even. That should be equals equals. Everyone okay with that? Does that make sense to everybody what I just did? The what part, Daniel? High index plus end? Oh, so this is just oh, I'm sorry, I get what you're saying. This is just checking So this is moving forward, yes, but at the same time, it's also checking, hey, is the current element even or not? Because that's the whole point of this function. So it'll basically return one or zero. No, the order does not matter. So this will return one or zero. And if this returns one, you know it's even. So it'll get the result from this current recursive call and then make the next one until we reach the base case. And then that's this whole. You could do it many ways. Well, wait, the recursive. What do you mean the recursive call? This part? Like, how are you thinking of it, Chris? You could flip the order of these. Yeah, you could do it. Yeah, you could do it like that. Okay, there's many ways of doing it. Probably. Honestly, the best process is just like Jared. Do you mean like tracing it out? Just I, hopefully we could probably do that another day. This one isn't really a tracing question. You just go slowly. Jared, look back at my lab recording from one of the quiz reviews. I covered one of those. I forget which one it is. But anyway, this is the question. That's it. Very simple. Any other questions on this? All right, we're ready for our last question of the evening. Unless we have time, we can do a quick postfix evaluation. I think it'll be on the Nighthacks YouTube channel, and I'll throw them on my YouTube channel, and I'll send the link somewhere in the Nighthacks server. All right, last question. Another recursion question. There's what I just did, basically. And I'll send these notes out too, actually. All right, 10 points. Imagine that a virus is spreading through an area that we can model as a 2D array, integer array of size n by n, where each value in the array stores the current level of virus at that grid location. The virus can be activated at a particular location. If that location currently has a virus level that is an even integer, then the virus level in that square increases by 1 and then spreads the virus by recursively activating the locations above, below, left, and right of the immediate location if they exist. If the virus level in that square was odd, no change occurs and the virus doesn't spread. Luckily, once the virus level in a square increases by 1 due to an activation, it can't increase again. Here is a small example of a before and after picture of activating the virus in row 2, column 0. So right here. We can see that this is even, so it'll be incremented. The one above it's even, so it'll be incremented. The one to the right's even, so it'll be incremented. The one down is odd, so it won't be incremented. But then we have to look at these ones as well. It keeps going. The 3 here is odd, so it doesn't change. The 1 here is odd, so it doesn't change. But this 4 will go up by 1. And from the 4, then I'm sorry, this 2 will go up by 1 from the 4. And then this 2 as well. And now we have to check these two. We already checked this 5, and now the 9's odd, so it doesn't change. And then this 8 gets incremented to 9. So I'll circle it. And then from this 2, the 7 doesn't change because it's odd. Now with this 8, the 4 gets incremented because it's even. The 1 doesn't change. The 11 would get incremented because it's even. And then we hit the end. Does that make sense how this works? Basically, yeah, but it only happens once. If it can reach them all. Complete the recursive function below so that it takes in a pointer to an array, so the array is stored in the grid, the value of n in the row and column of where the virus is activated, and updates the virus levels accordingly. Don't forget to make sure you don't go out of bounds in the array. The 2 is missing in row 0. Oh, thank you. My bad. This being corrected too. Now here's what the cool part about this question is. Surprise! Fill in the blank. So it's not as bad as it seems. I don't know if every professor covered this, but this is literally flood fill. That's all it is. So I think we should just tackle these squares one by one. Are these blanks one by one? So how would I know if a column is out of bounds? This should be pretty self-explanatory, I think. Let's take the first if statement. How do I know if I'm out of bounds using what we're given? Yes, if call is less than 0, or what? There's another option. What's the other way? Call is greater than or equal to n. Perfect. Call is greater than or equal to n. Does that make sense? That's just 2D array stuff. Okay. Then, yeah, n is the size. N by n is this whole thing is n by n. So then we only care about if it's even, right? So we got to take care of the case if it's odd. This is another base case. So how do I check if the current element's odd? If I'm at row and column? Yeah, grid at row call mod 2. And then you could say does not equal 0 or equals 1. I'll just do equals 1. Okay. So then if all these three base cases are not true, that means that then what does it mean? We want to increment that level by 1, right? Well, hold on, you're getting a little out of yourself, PTR. We got to take care of this blank first. So we just need to increment. We just have to increment the current element by 1, right? If it's even, which we know is true at this point, right? Does that make sense? So grid at row call, then the plus plus is already there. Okay, now all that's left is just make our recursive calls. And what do we have to do? We just have to literally just do the up, left, down, and right direction as it said. Then that's it. I mean, this really isn't that hard of a question, in my opinion. So now let's make our recursive calls. So let's go left first. So it'd be activate, and the grid does not change. The end does not change. Now, if I want to go left, how would I do that? With row and column. Row minus 1. Perfect. Row minus 1 and the column. And then semicolon's already there. Now, let me just copy this 3 other times so I don't have to paste it. I have to write that all again. Oops. Oops. I'll change this in a second, guys. Don't worry. Okay, so this is going to be left, right, up, down. And then let me erase these two. Because, oh my God, where'd it go? Where'd it go? Jeepers. Okay. What I just did. Oh, no, that one stays the same. Okay, get rid of this. Because, every time we're still using the same grid and end size, so those don't change. No, wait. Yes, you're right. My apologies. Yeah. So this is not going left. Well, let's start over. If I want to go left, how would I do it with this? Row column minus 1. There you go. My bad. So it'd be row call minus 1. Now let's go right. What do you think right is? Yeah, exactly. Row call plus 1. Now what if I want to go up? Is the column going to change? Yeah, row plus 1. No, wait, up. Be careful, up. It's minus 1. And then if I want to go down, it's row plus 1 calm. Now, the order of these doesn't matter. I just did the same way. But that's it. I mean, it's really not that bad in my opinion. I don't know about you guys. So, any questions on this? All right. Should we do a post-fix evaluation question? All right, let's do that, and then I think we can call it here. Let me find one real quick. There's one in here. Nope, that's infix to postfix. Another infix to postfix. Okay, I got one. Spring 2023. Let me go get it. Give me one moment. That would be here. All right, now it's going to be from iPhones. All right, you get to take a journey to the internet, the interwebs. By the way, if you ever want a fun game that's like CS based, play a party game. It's called Survive the Internet. It's really fun and quirky. I don't know if you've heard of it. Here it is. Here. I will just put that down here. All right, here we go. Postfix evaluation. So, okay, if you got the concept of the coding stack question we did, it's literally the same thing. That's all it is. Except now we're just doing different operations. So now the difference is we're pushing in operands, and then whenever we see an operator, we just pop the top two things and do the operation. So here we go. 4. Where do I put it? Push it. Perfect. There's like no priority here, by the way, or anything. Okay, 3, it's a number, so you push it. Now a plus. You pop the two top things. So in this case, 4 and 3. Do the operation. Now, if I recall correctly, 3 becomes B. So you always do the first thing becomes B. The second thing is A. And then you do A over A, the operate, then you do A, whatever the thing is, B. So in this case, A plus B is 7. So then I'm going to push in 7 to my stack now. You don't put in the original numbers here. You just put in whatever was done. So I have a plus. Put in a 5. Put in a 2. Subtraction. By the way, you should never get negative numbers with this. So now B is 2. A is 5. So 5 minus 2. A minus B is 3. And now we're going to put in 3. This making sense so far to everybody? All right, cool. Multiplication. Well, I think that's pretty, I don't need to write it out. 7 times 3, 21. Yeah, you should never get negative numbers. Yes, yes. Okay, 8, put it in. 7, put it in. We've hit A. So now keep going. 21, 8, 7. And we have 9. So you kind of could start doing this in your head. What's 9 plus 7? 16. The only ones you got to really worry about are subtraction and division. Then 16 plus 8, 24. Put in a 6. Okay, now divide. Oh, we hit B already. Jeez. Okay, now divide. Is it going to be 6 over 24 or 24 over 6? Got one answer. Any more? Yeah, exactly. 24 over 6. So that is 4. We have a 9. We have a 4. It's a lot easier than to fix the postfix, in my opinion. You just sometimes you lose track. Okay, we have a subtraction. 9 minus 4, you're going to get 5. And now we hit the end of C. So on the side, we'll have 21, 4, and 5. Now we have multiplication. 5 times 4, 20. Oops. And then lastly, is it 20 minus 21 or 21 minus 20? 21 minus 20, which is 1. And you should only have one thing in the stack at the end. And that's your final answer. 1. That whole thing equals 1. A lot easier, right? Okay, I think that's enough questions for tonight. Who agrees with me? I'm gonna stop screen sharing here. Okay, before you all go, to those who stayed on the whole time, thank you. I hope you all found this helpful and liked my teaching style. Um, I'll be back tomorrow, probably do some more questions. I don't know if I'll do all of them tomorrow, but I'll do a lot of them. And new Ahmed in the making. I appreciate that. Um, and I know day 3, someone else is doing a lot of the questions, but I'll do as much as I can. I enjoy this a lot. So, anything else before you all go? Any other questions, comments, concerns? And again, I'll get this recording up as soon as I can, and as soon as AJ can. So, all right, take care, everybody. We'll see you all later.